SIR niche areas related to environment and toxicological aspects. He had delivered several invited talks at IITs, IIMs, universities, etc. He had contributed as a member of organizing Indian International Science Festival IISF under CSIR activities in collaboration with other partners. He had received recognitions for outstanding contribution as an expert in Northeast Student Conclave during IISF. We would like to welcome Professor V.P. Sharma sir. Professor V.P. Sharma sir, now the stage is yours. Thank you so much.
Thank you a lot, Arpit, Ashutosh, Dr. Ashwini, all the faculty of the prestigious university. And am I audible?
Yes, sir, you are audible.
Okay. And I will try to have the slides from here. In case it is not possible, you can have the slide from your end within a short interval.
Sure, sir.
I think you can have the slides from your end. Arpit?
Just give me a second, sir. Just give me a second. I hope it is visible, sir.
Yes, only it need to be at the full screen.
Is it done, sir?
Yeah. Okay. So I start with first of all, I would like to thank all the participants and the organizers for taking up a very, very important aspect of the research methodology and to make understand all the students on the various facets. So on the first slide itself, we can say that as you see, that this is a special day where we can have the greetings to each other on Ram Navami, as well as this is a particular phase when we can say there is a good enrichment on our farms, and at the same time the weather is very conducive to each other. When we think about importance and strategies toward quality improvement, this imbibes many of the factors, so I thought it to be taken as a holistic approach. Next. If I say what is research, it is a logical and systematic research for the new and useful information on a very, very important or a salient topic, which can be a point of concern, or I can say under the aims and objective, what you are focusing, why you are focusing, and what is the genesis of your concept of the idea, and how you want to prove that concept into the reality, taking the help of scientific and social problems in mind. When we search about the data, we find there can be a significant review of literature can be there, national and international, but at the same time, the information has to be gathered, collected in a systematic manner, converted into knowledge and then to wisdom, and then how we can utilize it for the benefit of the society. When we say about how to get the collection of the data, we can have the access to the different journals, books, and the periodicals of different type. At the same time, nowadays the social media, blogs and other things are coming up. We can take the advantage of it. Sometimes it is felt that the data is too much and you need to analyze it critically, or you want to subcategorize it. But in some of the cases it has been found that the data is very, very less and you need to collect and compile or get through the questionnaires or it can be monitoring and management of a particular project or a particular study. It depends what are the conditions and under which you want to measure. For example, if I want to have the monitoring and management of a food assembly, the situation will be different. In a unit where the beverages are being manufactured, the parameter, the guidelines may be different. So we have to understand where this slide really focuses to that the scientific research is an art, it is a passion, and that passion has to convert into a profession. And this is only the profession where we can say that you can cherish, that you can enjoy the working in the laboratory, in the open field, or into the societal level. And every member or every type of student can be befitting, only the need is of chiseling the capabilities. Next. So when we say about the management, I would like to say there is a managing of the men, women and children in a tactful manner. In the different definitions of management, whether it is a financial, economical or human resource management, the experience goes, whether it is IITs, IIMs and others, that we have to manage the things in a very, very critical way, and we have to involve or understand the requirement of the men, women and the children or the population in total. When we have to see this, we can adopt, we can accept the procedures, methods and techniques which have been validated, or if it is a new method, there is a need of further validation and standardization, which most of the laboratories in biotechnology, zoology, botany, chemistry and others, they keep on doing, whether it is for parameters like characterization using the NMR, IR, UV and others, or in the laboratories where there is an analytical field, we have the inductive coupled plasma, atomic absorption spectrophotometer. In the units where we are having the biotechnology, biomedical and others, the things like RT-PCR and others. Recently, when during the COVID, certain laboratories were asked to establish the COVID facility, and throughout the world we have seen that there was a different level of competency at the different positions. When I use the word competency, the competency means that it is not only just the qualification, or the MSc degree or the PhD degree, but it is also what you are really competent to perform as a contract, as an understanding between your sponsor and the plan of work with proper bar chart and per chart. When we go about the applied research, how we can utilize the basic research into the applied aspect becomes very important. And this application of the research is helpful to take the things in the benefit of the society or to take up further studies at the longer run. Taking into consideration the example of plastic and polymers, which is a subject area of biotechnology as well as chemistry, botany and others, because this is where we can say, first of all, the monomer are there, the multiple unit of it will be the polymer, and if you add to the additives, they is making the polymer into a plastic compound or a molecule or a particular fabricated product. So we come across this example, and the same additives like phthalates, the phthalic acid esters, bisphenol A, the flame retardants, when they are added as an additive, these additives may have some toxicity. So we have to understand what is the limit of the toxicity, and because everything cannot be said as good or bad. There is in fact a very thin lining between good or bad, because if it crosses the limit, then it is toxic and hazardous. Within the limit, it may be permissible, at the same time it may be useful for the production of a particular material. Next. So the R&D management should be focused towards selection, formulation, exploration, collection, refinement at the different stages, and this involves the different type of processes, including the technology development, for which in the present era we are looking forward through the startups or the entrepreneurship. So whether it is the prestigious any university of the world, they want to see that how you are converting the basic research or the fundamental research to the applied, and applied to the real benefit in the form of technology, patents and so forth. The patent writing is also very important in the way that it is an intellectual property right, and you have to safeguard the interest of the individual who has developed it, whether you or your group or your university or the country's aspect, because it is the, and now we are living in a global scenario where we want India to be a superpower in the terms of development, at the same time making the things understandable to the masses. So Guru Dakshita, or we can say Vishwa Guru, अगर आपको विश्व गुरु बनना है, अच्छा बनना है, समझाना है, तो हमारी जो प्रेजेंट जनरेशन है, हम 15 से 35 ईयर के जो ग्रुप है, जिसमें हम बहुत सारे स्टूडेंट्स हैं, उनको मैं अपना टारगेट ग्रुप कहता हूँ, और जिसपे हमारी जो देश की R&D मैन पावर है, वो हमारे लिए एक बहुत बड़ा क्रेडिट है, बहुत बड़ा हमारे लिए एक अपॉर्चुनिटी है, बहुत बड़ी एक हमारे लिए संभावनाएं हैं, और इन संभावनाओं के बीच में हम ये ढूंढना चाहते हैं कि हम रिसर्च को कैसे आगे ले जाएं। कभी कभी फाइनेंशियल एस्पेक्ट्स हमारे लिए हर्डल बन सकते हैं, लेकिन अगर प्रॉपर मैनेजमेंट किया जाए, प्रॉपर कंसेप्ट को देखा जाए, हम प्रिसाइज और एक्टिवली इसको फोकस करके वर्क करें, तो इन चीजों की कमी नहीं है, उसको सही तरीके से समझने की जरूरत है। तो हम ये कहेंगे कि टेक्नोलॉजी, लाइसेंसिंग, इनोवेशन, मैनेजमेंट, कॉर्पोरेट मैनेजमेंट और वेंचरिंग एंड इंक्यूबेशन, ये अपने आप में भी इम्पोर्टेंट है। जो रिसर्च और जब हम R&D मैनेजमेंट की बात कर रहे हैं, तो यहाँ पर 3 कीवर्ड आ रहे हैं, रिसर्च, डेवलपमेंट, और जो हमने पहले आपसे बताया, मैनेजिंग द मैन, विमेन एंड चिल्ड्रन इन अ tactful manner so that you can utilize the benefits of whether it is the agriculture produce or the bioplastics or the chemical products or the physical transformations for the betterment of a particular aspect of work. So it is not only now the one particular branch of chemistry or biology. That is why in our institute or in our CSIR system, we have the Academy of Scientific and Innovative Research, Council of Scientific and Innovative. CSIR full form is Council of Scientific and Industrial Research, while for ACSIR it is Academy of the Scientific the flora and fauna, I can say, there is also the need of the biotechnologists. So your area is very, very catchy and responsive at the same time paying. Next. Now we can go a bit fast because I've given you a basic idea. When we speak about the research methodology and teach up for the PG students or to the PhD scholars, the basic as per the UGC guidelines, the first 6 months has to be recapitulated. We have to make them understand why it is needed and why, how, when, where and who did it, why it was performed, on what is performed. If we want an answer for all this, we have to understand that the research methodology is a very, very important aspect. So understanding of how this has been performed in a systematic manner, which instruments were taken into consideration, who performed it, where it was performed, we have to go into the details which other speakers might have covered during the last few days, and I was able to see the outcome of few of the presentations and other things, and it was very, very encouraging. And I compliment the organizers for taking all this and a wonderful draft of the total program. Next. So the quality system concerned, quality should become as a habit. Whether it is any day, it is and the keywords which I have focused here is there should be a planning, performing, monitoring, recording, archiving and reporting. So the good quality system, whether it is ISO 9001 or any of the guidelines which concern, for example, in biomedical field, IS 15189, or in the water sector, IS 10500, or for the laboratory setup, ISO 17025, each of them focuses on good planning, performance. So the keywords has been covered here that you should understand and you should memorize it, that whenever you start a work, you start from planned, performed, monitored, recorded, archived and reported. So whether it is any of the faculty members, if they have to see that whether it was done in a rightful manner, they can use these words to recapitulate and to find that the work was done with a purpose, there was certain hypothesis, what were the materials chosen and how the procedure was adopted, what were the results and ultimately what was the conclusion. And these conclusion and results should not be in the newspapers or the registers. This should go for all the years to come, so they should be properly archived. So whenever you want a particular data, it can be retrieved from the archival setup. So the modern research or the modern system says that even all the PhDs or the theses which have been compiled, they should be maintained. It should not be beating about the bush, but rather going ahead in the different directions. Next. Next slide. So the objectives, how we can, when we are taking the objective framing, promote the quality and validity of data, protect the human health and environment, and facilitate the recognition of data so that you can have prevention of duplication. You should take into consideration the animal welfare. Now the ethical committees are there, human ethical and animal ethical committees. So that when you do the experimentation, it should not be that you are taking the undue animals, instead of 5 or 10 animals, you are working on 50 animals just to have the more statistical point of view. Because we cannot be cruel to the animals. So the ethical committee says AMC and others. So I would suggest that there should be a logbook, the proper maintenance of record, and the best utilization of the equipment with the proper date of calibration and its due date of calibration. All the beneficiaries, all the students or the faculty who utilizes a particular equipment should mention their name, time and detail when they have used, and in case the instrument is out of order, which is very common, you can write at the logbook that it was out of order for this period. Don't hesitate. And if we are transparent, we are understanding, then there will be no problem in the total setup, whether it is the monitoring or management by the university or the lab experts and by the HOD of a particular department. So we can have also the database and tell to the other neighboring universities that we have this facility. For example, in our own system of CSIR, we have generated analytic CSIR to tell each one of the members in the country that what equipment is available in which laboratory and how you can utilize it. Fortunately, all this information is available on the website curate records. The same, now you can say, what is the difference between a template and a record or a document? A template is just a format, while after filling it, it becomes a important in document, and this document has to be maintained in a systematic manner for years, which you have decided. This becomes as a record. For example, your mark sheet of the high school or BSc or MSc, that is now a record, and that record becomes important to take you from one step to the another. Similarly, the papers of organization, the legal papers, the legality of the organization. If I say that particular university is legal or not, or the university or the departments are legal or not, or your entry to the system as a student, are you having an ID card? The ID card itself says that you are an authorized student of a particular university. The enrollment number, roll numbers. So these papers, these documents become as a base for confirming that you are a authorized student or a faculty of a particular university. So similarly, we can have the different type of documents. It can be personal, licenses, insurances, health benefits, financing, and so forth. And if you comply to all this in a systematic manner, then we can say that you are following the set procedures. The inventory is the correspondence, whether it can be in the digital mode or in the hard copy. In the present era, we are finding the digitalization, but again you have to take the protection that the hard disk and they are properly maintained. The computer system should not go out of order, and your all data of last few years is wasted as such. So we have to take care of the proper archiving, and even the electronic data has to be taken into consideration. Next. So the results must include, which I was emphasizing, through the typical questions now I'm asking, what was done, how it was done, when it was done, and who collected the data. Are the study files maintained? And if you are maintaining it, it will help us to get the data, and when you are completing your PhD work or a particular project, all this will go in a better informative through the different modes of presentation. So the data of environmental conditions is also very important. For example, if you are conducting any study on 30th March 2023, what was the temperature, what was the pressure, and what was the humidity in your room may become important, because in some of the cases the data may vary with the seasonal variations or from region to region. If you are performing a particular study in Satna, that may सैंपल लिया, कितनी क्वांटिटी में लिया, कब लिया, कहाँ से लिया और किसने लिया, और उसका उस दिन डेट क्या थी, क्या टाइम था, ये सारी चीजें भी आपके लिए इम्पोर्टेंट होती है। इसी तरीके से जब आप एक्सपेरिमेंट कर रहे हैं तो उस एक्सपेरिमेंटेशन का दौरान के डेटा का भी कंपाइलेशन, अब कभी कभी ये लगता है कि ये बहुत ज्यादा डॉक्यूमेंटेशन है, लेकिन ये आपके सही डेटा और आपको प्रोटेक्ट करने के लिए, आपको आगे बढ़ाने के लिए दोनों पहलू पर आपके लिए आवश्यक है। सो द प्रोजेक्ट लाइफ साइकिल अगर हम कहें तो स्टार्ट फ्रॉम कंसेप्ट राइटिंग टू द रियल प्रोजेक्ट राइटिंग एंड फंडिंग एंड अल्टीमेटली रिपोर्ट एंड यूटिलाइजेशन सर्टिफिकेट। बहुत जगह ये होता है कि सन 2012 का आज यूटिलाइजेशन सर्टिफिकेट मांगा जा रहा है, तो आप कह रहे हैं कि भाई यूटिलाइजेशन सर्टिफिकेट तब हमने जमा कर दिया, अब नहीं है, तो उसके आपको डॉक्यूमेंट्स मेंटेन करने पड़ेंगे कम से कम 9 से 10 साल। और अगर कुछ लोग ये समझते हैं कि रिटायरमेंट के साथ हमारी रिस्पॉन्सिबिलिटीज खत्म हो गई, तो भी मैं यहाँ पर बताना चाहूंगा, आज के परिव्यू में, आज के परिप्रेक्ष्य में अगर रिटायरमेंट के कुछ सालों तक डिफरेंट ऑर्गेनाइजेशन ने ये बाइंडिंग कर रखी है कि 5 से 10 साल तक आपसे डेटा या इंफॉर्मेशन मांगी जा सकती है। नेक्स्ट, so the keywords to remember: what, how, when, who, where, and data should show protocol was followed, process complied with SOP and results are there. This and दूसरा पॉइंट है कि लैब में काम करते समय हमें एप्रन पहनना, पर्सनल प्रोटेक्टिव इक्विपमेंट, वेट लैब की सिचुएशंस अलग हैं, ड्राई लैब की सिचुएशंस अलग हैं, कौन ऑपरेटर है, डेटा ऑपरेटर कौन है, वेरीफाई किसने किया, क्या ये चीजें डायरेक्टली प्रॉम्प्टली एक्यूरेटली मेंशन की गई, इसकी भी आवश्यकता है। Next, now we can go fast. So there can be international cooperation and it includes inclusive growth, digitalization, and this should follow the different sectors. For example, in case of laboratory, it is 17025. In case of a food sector or in a sector where you are getting the good restaurant and other thing, ISO 22000 is applicable. Next.
गोविंद सिंह
So
का पासवर्ड वो
this
बता
takes
देंगे
me
ना
to the
आपको,
next
फोन कर
slide.
लीजिए उनको।
The ISO 17. This is a
OTP
compact
चाहिए।
slide of ISO 17025,
OTP चाहिए।
and it says about the general aspects, structural requirement, resource requirement, process requirement, and the management requirement. At least once in a year, there should be a management review. It is better if you can have 2 times in a particular year. The processes should be well structured. The resources should be available. Sometimes we say the resources are not available. So you should plan at the beginning, what are the resources, how I can get access, and if it is not available in your university, how you can have access from other universities or the other organizations of repute. Next. So to conduct and support this environmental health services, we need the of pharma products or others, or good in wherever there is a good there is a manufacturing. In the case of laboratory, we need good laboratory practices, and this has to be created as per the demand of the OECD. And whether we are calling OECD or the NABL, we are controlled through the Quality Council of India in India. And this organization helps us to have the quality control, verification, customer satisfaction, standardization, and the quality system is revolving along the 7 points, which is focused in the corner of this slide. Next. So, the GMP versus GLP, if you have to see, you have to understand in the manufacturing unit what is the requirement, and the laboratory, and in some of the cases there is a overshadowing of this because there is a controlling, ensuring, improving of quality for the different processes and practices. Next. So this takes to the aspect of what is the purpose behind it, to promote the development of quality and validity of test data for understanding for the safety evaluation of chemicals, pharma products, food products, cosmetics even. And the cosmetics are very demanding in our country and at the global level. Moreover, there is also demand of personal care products. So in the fast moving this scenario, we have to have the quality control and quality assurance so that there can be accurate, precise and reliable data can be generated. Next. So these says about again what are the general requirements. Premises should be clean, personal equipment, chemicals and reagents, good housekeeping, maintenance. You should have the CRM and RM, microbiological cultures, and the system should be internal quality as well as external quality should be ensured through the audits. The periodical management reviews, the SOP should be in place. They should be maintained and updated from time to time, which I am doing at our institute since 1999 for NABL, and for GLP we have from 2014. And you can take the advantage of the GLP or NABL studies at our institute, but everything is sponsored because we can't go for free and we need to have the sustenance of the system. So the protocols, raw data, and even I say to the universities like you that you should follow the system but not on a free basis, because if something comes free, it is not equally credited. So take the benefit of your hard work and also take the benefit of your space, the equipments and so forth, because you are spending a significant amount on all these. Whether it is the Vice Chancellor or the Director of Institute or the country head, I can say each one wants the proper return of interest. The ROI is important in many of the cases. Next. So the laboratory infrastructure should not be that we should not be praising that it happened about 50 years back. We have to change with the time. Our even furniture, our ventilation, lighting, the conditioning, the different type of sensors we can utilize in our laboratory. So every 5 to 6 years or periodically, your organization need to upgrade your system, and the obsolete model should be scrapped properly as per the norms of the government. So there are set procedures of the manuals laid down by the government organization for the purchase as well as for the disposal. We should follow, and we should also make the procedure in the standard operating procedure for purchase of the new equipment, training of the personnel, and also for the disposal of the old items. And it should be in coordination with the concerned authorities of the organization. Next. The training is very, very important. If we have everything and our manpower is not trained properly, the things will go out of order. So the managers or supervisory staff, analysts, technician, helper and others. For example, if Dr. Ashwini or Dr. Astos says that now I am at a professor level, I have got all education in this stuff. Even myself, if I say that I have rendered so many years of services and thus I don't need any training, I think I will be wrong on my part, because I need a proper upgradation of the knowledge from time to time. Sometimes we also get the knowledge through our students, or we upgrade our things from the questions what they ask. So we should understand that there is an importance of capacity building should be a continuous feature. Next. The capacity does not need only the four walls. It can be in the open, it can be in the field, but it should focus on the different type of aspect, starting from the personal protective equipments to the real working. The figure at the corner tells you that how you can be a good mountaineer, and for that good mountaineering and so forth, the periodical training and upgradation is needed. Similarly, in administrative system or in IAS and IPS and others, they also obtain the training, though they may be at the highest position. Similarly, the teachers, the faculty of the different organizations and the FDP programs of the different universities is a step towards that. Next. Next. So the management requires resources to be managerial and taking the things into consideration for following the different policies and procedures. Next. The total quality system is again a management approach to have the long-term success through customer satisfaction, and it involves the different type of risk management cycles, and there is a concept of 360-degree resolution. The 360-degree resolution says that we should understand about the culture, communication and the commitment. The good communication is also important. आपने बहुत कुछ पढ़ा, बहुत कुछ समझा, लेकिन अगर आप प्रॉपर प्लेटफॉर्म पे जवाब ना दे पाए तो आप अच्छी पोजीशन के लिए, अच्छे एक इंडक्शन के लिए, एक अच्छे अपॉइंटमेंट में हार डालते हैं. इसलिए जरूरी है कि एक अच्छा कम्युनिकेशन आपके साथ और नेवर बी डिप्रेस्ड. नेक्स्ट. So the good manufacturing practices, they want a person who is compliant to the system, he is aware about the system and he knows what are the requirements in perspective of food, pharma or medical requirements. Next. So the project evaluation, sometimes there is a assigned work of only the project evaluation and you are not to do with the starting or the experimentation. The science component is not there, but there is a component of whether you are following the aims and objective, mission, the risk identification and potential corrective and preventive measures. So as to be smart, we have to take the consideration of strategy, organization, execution, development, and this will help the project management at the better level. So I would say we need good managers as well as good leaders. Next. This again taking you the same fundamentals for when I say smart, you should be specific, measurable, achievable, realistic and time oriented. Next. This includes the aspect of inclusive and exclusive growth, and it involves social, human, economical and environmental aspect for the betterment and attainment of sustainable development, which is the target for 2030, and it may extend for the years ahead of it, and thus we in the present scenario are looking forward for sustainable development goals, and our country is not in a very good position, but it is improving, I can say, and thus it is the responsibility of each one of us to follow for the 17 different sustainable goals set up by the International Forum. And when we are following the G20 and SDG goals, it gives us satisfaction and it takes us to a path of glory and recognition. Next. conferences and so forth, we can take the advantage, write good articles. It can be a review article or a publication, but I would say that take the into consideration there should not be plagiarism. And when we are teaching each other, we are adopting these concepts just to educate, but at the same time I would say this is for understanding of the subject. We are not saying that this is one property or our property. If you say in the IPR point of view, then it becomes very, very important. But as a teacher, as a faculty, we should take the advantage of whatever has been done in the past. The good journals, the good literature. But when we are writing something, we have to take into consideration the aspect of plagiarism. Next. So the minimum plagiarism which is permitted or less than that, even what is anticipated, should be there. Nowadays there are areas which are coming like forensic science system, in the area of water, or in the food sector, or in the pesticide residues in our food and vegetables is very important. Even in the country there is a high demand in the import and export sector of the persons or the professionals who can really monitor about the real quantity of the pesticide residues. Next. So in the genomics cases or the metabolomics is important in the clinical and sports anti-doping, veterinary diseases and so forth, or in veterinary materials. Even our the food and material which we are giving to rat, mice, guinea pig, or to our animals, or to the animals which we are having in our farms, we have to be careful. So it becomes very important to understand each of these phases. Next. This takes me to the aspect of capacity building HRD development on a regular basis through the skilled workforce and happier staff. If your staff is happy, you will be able to give good product and good services to the society. And this also helps in development of technologies which will be going far away in the society. Next. So the data quality should be simple, and we have to take into consideration the quality and the quantity at the different. The door for the enrichment inside or outside is double process, and the quality should become a habit, starting from your toothbrushing to the end of the life or the end of the day. And this should take into consideration all the aspects of nearby society. Next. So we come to the aspect of quality assurance at the different phases, whether it is the food additives, feed additives, industrial chemicals, and there are procedures. We can't say that we are ignorant about the procedures. The procedures are there, they are being updated, and many of our scientists are working in the different capacities at the policy framing and formulation, whether it is the Indian Pharmacopoeia or Bureau of Indian Standards or ASTM and others or ISO. So our country, our personals, the student like you and the faculty like you are having a great potential. Don't be limited in the boundaries of only your institution. I would say come out of the university, think what you can support to the international platform. You have a great strength. Never think that you are undermined, and you have a great potential. You can utilize it for the development of the society as well as for your own well-being. Next. So now coming to nearly the conclusion of the different slides, we can come to the aspect of green chemistry and understanding of food safety management system. Next. This takes to the ecological consideration, ergonomic and agronomic concepts, and following of drug and a poison. Same thing may be a poison, for example, common salt. If the common salt we are using at our home, we are using it for day-to-day purposes, but if it exceeds the limit, it becomes toxic. So we have to be careful, and what is the dose and how it is being transfused. Even normally we are taking 0.9% normal saline, but it is, if it goes higher than that, it may be hazardous for any of the human beings. Next. So attain excellence. Now I'm coming to the perception through your eyes. What you see, how you see, and when you are going for a travel, you might be thinking that the woods are lovely, dark and deep, but we have promises to keep and miles to go before we sleep. And miles to go before we sleep. It is your perception, how you think, how you analyze, and what you really do. The same perception can change with the coming years or with the coming scenario. I would look forward that you take care of your eyes, be a wonderful human being, and help the society by taking the new things ahead. Next. So I can say thank you for your patience hearing, understanding, and if you have any queries, you are always welcome, and you can come in group. You can have the outreach activities, educational visit to KSR Indian Institute of Tolstoy Research, and take the full advantage of our campuses, which are scattered in two ways, and 37 laboratories and the field stations. We can say we look forward for more and more benefit to all our countrymen, to all our students, and we see a very, very bright future for each one of them. Thank you all. If you have any question, I would be happy to ask those. And I also pay my regards to Dr. Ashok Srivastava, who is here, Dr. Ashwini, Dr. Ashutosh, the different faculty from the university, and other stakeholders from the different corners of the world.
Thank you, sir. Your lecture was very elaborative and insightful for us. Your sir has covered objective of R&D, R&D management, and research methods, and difference between research method and methodology, and research ethics. You also covered, and to avoid similarity and duplication, and you also emphasize the time and resource efficiency during your lecture, and what will be being covered during our result, means what was done, how was done. These are the important aspects of any researcher. And you also covered the ISO IC 7025, that is very mandatory for all laboratories, and people working in the laboratories should be know about this guidelines actually. And GLP, you also emphasize the planning, execution, and maintenance of before going to start any R&D work or a research, and quality systems, total quality management. These are also very important topics covered by you, sir. Good manufacturing practices and project evaluations. These are the very important topics that was sometimes missed by our group people working in this area. And every time we have to, you also aware about us regarding ecotoxicology, means some you are also aware us regarding exploitation of natural resources that will cause alarming situation regarding we can say regarding our fresh water and fossil fuel and other things. These are the, so we have to avoid overexploitation of natural resources. And you also cover climate, energy, and air quality. These are the very important aspects, because what we are going to give our next generation, it is our responsibility. And you also cover the genomics, how we include genomics and importance of genomics and metabolomics in toxicology, and OECD principles, different ESTM and ISO standards, and these are the very informative in a very short time period. Even I have taken 1 hour, and but you also told us regarding circular economy, that planning, organization, and development. These are the various aspects, and you have covered. And thank you very much, sir. And we are glad to find you among us actually. And I would like to request audience ask to sir, and that will be good to you. And obviously, you have learned a lot from their slides. Their slides are also, and their presentation is also self-explanatory. So please ask some questions you have. Oh,
At this moment, I would like to say my special regards to Dr. Sivesh and Ashokji, the Vice Chancellor of the University, as well as for thanks each one of you for your valuable comments, taking the things in a positive perspective. And as there was a question just now, how we can reduce the cost, I would answer in the way that you can have the reduction of cost by sharing of your facilities and expertise. At the same time, the resources are available in the different laboratories just by writing a letter and taking the SS through the management head. I think just taking into confidence, you may be able to take up the studies, but the proper recognition of the other partner is also needed. Sometimes in some of the laboratories we find that the benefit was taken, but it was not properly recognized. For example, if I take any help from you, I should duly recognize in the paper and publication. This will also be a proper ethics. जिसे कहते हैं ना दिल की आवाज, एक दूसरे का सम्मान और दूसरे के साथ हम अगर काम कर रहे हैं, लेबोरेटरीज को यूज कर रहे हैं, तो हम उसको प्रॉपर रिकॉग्नाइज करें, अंडरस्टैंड करें, एडियर करें. हमारे ख्याल से इससे हम चीजों को कम कर सकते हैं, कीमत भी कम आएगी और हमारा काम भी अच्छा हो जाएगा.
Sir, thank you, Dr. V.P. Sharma, sir. This is Dr. Kamlesh.
Thank you.
Thank you for being with us, and you have given very nice insight about how we can get NABL accreditation. Actually, we are going towards that direction.
Okay, I wish all the best.
So, sir, we need your rigorous help in this regard.
What I suggest I can suggest to you that the 3 or 4 of the faculty can come to the CSIR IITR to have one-to-one understanding how we are working.
I have already visited Gheru campus and your lab, and in fact,
yes, I visited earlier. Now, I would say it should be a continuous process, and we can upgrade our system. And
definitely, sir. Definitely, our team and I will come, and definitely we will learn some. So, thank you so much, sir, for being here.
Thank you. Okay, so I leave now with the permission.
Thank you, sir. Thank you very much. Now I would like to request Arpit sir, and before going to towards Arpit sir, I would like to welcome Professor Ashok Srivastava sir, distinguished professor from IIT Delhi. He is the alma mater of SPTU Kanpur, and I also done my 2 degree from there only. So I have feeling very much privileged to find sir among us, and once I call her sir and say regarding about this event, sir ready for that, and without any lack of faith, sir is always open, and sir is always tries to spread information in the form of their presentations by service societies, and he loves actually student crowd. And over to Mr. Arpit Srivastava, sir.
Good morning, everybody.
Thank you, sir. Thank you so much. So moving on next with the second part of this technical session, we have now Dr. Ashok Kumar Srivastava, sir. We welcome you, sir, in the research methodology in current a national workshop which is going to be organized from 27 to 31st of March, organized by Directorate of Research and Department of Biotechnology. So we would like to welcome Dr. Ashok Kumar Srivastava, sir, who had done his BTech and MTech degree in Biochemical Engineering from HBTI Kanpur in 1976 and 1978. He received his PhD degree from the McGill University, Montreal in 1990. He had 42 years of industrial research teaching experience in the area of biochemical engineering and biotechnology. He had been the faculty member in the Biochemical Engineering and Food Technology Department at HBTI Kanpur for 10 years. Thereafter, he has been associated with Department of Biochemical Engineering and Biotechnology, IIT Delhi, for about 30 years, wherein he had been the head of the department for 3 years. He is a recipient of several awards and scholarships, for example, National Overseas Scholarship Award of MHRD, He left university, the Netherlands, Biotechnology Overseas Associateship, Germany and New Zealand, 3 months each. He had 111 journal papers, 165 international and national conference presentations, 6 patents to his credit. He has been the PI and co-PI for 20 sponsored research projects. He has also established state-of-the-art Center of Excellence for Mass Production of Biopolymers from the generous support of DBT New Delhi. He had been supervised 21 PhDs and 76 master theses. His main interest is in the bioprocess optimization and scale-up for microbial, plant and animal cell cultures and development of novel bioreactors for mass-scale cultivation. We would like to again welcome Dr. Ashok Srivastava. Sir, now the stage is yours.
Thank you very much. I appreciate it for the kind introduction. Namaskar. I am going to talk a little bit methodology to enhance the or rather to accelerate the research and optimize it in minimum time. So that will be my focus. So let me share my PPT. Can you see my slide?
Yes, sir, it is visible, sir.
And voice is also okay?
Voice is also okay, sir.
Wonderful.
Sir, just make the slide in the full screen mode.
I will just make it slideshow, yeah. Thank you, yeah.
Sir, one more thing, we would also like to invite Professor Shivesh Pratap Singh, sir, who is the convener of this particular national workshop. So, Professor Shivesh Pratap Singh, sir, we welcome you also on board. Thank you. Now, Ashok, sir, you can please proceed.
Thank you so much. So, as the name says, we have a lot of tools, like interactive multimedia, multimedia animation tools, modeling tools in the public domain, and unfortunately, not much people are able to access that because of the lack of awareness and all that. So, I decided to expose you in that areas, So that's what is my focus, I have also developed a virtual lab wherein we have the protocols for doing different kinds of fermentation, modeling, and then how optimize it, and so on and so forth. So that will be essentially I'll be focusing. So before going to that, a little brief background about the virtual lab, why it is important and all that. So as you can imagine, there is significant increase in the newer educational institutions in the country, Good laboratory facilities and teachers are required for quality education. When there is growth in masses, we sacrifice on the quality. So therefore, we have to have a platform where we can just expose the student to the best available kind of material available in the biotechnology, and what are the kind of traits and secrets, and what are the tools to really do the research faster, since it was a kind of a workshop. So it will be kind of a little bit of my lecture and majorly demonstrating the different tools available, particularly my VLab, for doing the research in the area of fermentation technology. So yeah, the good laboratory facilities, teachers are required for good quality education. Establishing state-of-the-art laboratories and attracting quality faculty for newer institutions is becoming a challenge. You cannot have faculty of the caliber of like top institution, but nevertheless, if we really encourage a student to really get benefit for these kind of labs, virtual labs, and the material available in the public domain, they can be really trained in a very nice manner, So that is what is the message I want to convey. Why it is important, virtual labs? It's like virtual labs are any place, anytime, any pace lab, These labs are available in the public domain, in the internet. If you have the internet, you can go to any lab there, and any time you can really access that. Not like your professor has come for 1 hour and you have interaction for 1 hour. Here you can visit again and again till the subject matter is clear to you. So that is the benefit of these labs, And we have access to quality teaching. Fortunately, we have access to quality teaching material in online laboratories to reasonably large number of educational institutions. A lot of labs have come, as I will just go along and show you. So these valuable. You should take the advantage of this, and this will supplement the classroom instruction which you are having, in your institutions, So teaching learning process becomes more enjoyable by the use of a multimedia animation in the classroom. Generally, it's like a chalk and talk, So the professor comes, he writes something and gives a lecture, and after you go, just if you want to revise that, there is no option available. You have to go to the textbook, which are bulky, and you start reading 2 pages and you go to sleep, things like that. As opposed to that, here the concepts in the virtual labs, they are demonstrated by the multimedia animation. So it becomes interesting, You can turn it on and understand whatever you forgot, and that way learning becomes more easier and faster, So it's a paradigm shift. VLab is a paradigm shift in the student-centric online education. Fortunately, Government of India is making aggressive efforts to develop the quality teaching material through NPTEL. A lot of deals are there, and a lot of virtual labs. A lot of top institutions, IITs, ISCs, they have developed labs in your area of your subject matter, like for example, biochemistry, microbiology, bioinformatics, environmental microbiology, bioprocess engineering, and so on and so forth. And it's freely available. Fortunately, there is no charge on that, So that is also a good thing, These resources provide free access to the online laboratories to reasonably large number of educational institutions in the society. So that is what is the advantage of the virtual lab. Now I just say that in the older times, suppose the professor wants to introduce you, like why biotechnology gives the definition, it's defined as application of scientific engineering principle and to the processing of material by biological agents to provide goods and services. What is science in engineering principle? It's like microbial technology, biochemical engineering, microbiology, biochemistry, etc. And what are the biological agents which are taking part in this? Microorganism, plant and animal cells. So how this plant cells grow and how we can make them grow faster and how we do minimum experiment, because these fermentation takes longer. So for that you have to understand some kind of technique. You have to grow them in optimum condition. So for example, you are using the media, so the media has to be optimized. Then you have established the growth kinetics, let us say, in the shake flask or the bioreactor. So that has to be really optimized, otherwise you will be just producing suboptimal concentration of the products, and that will not be good. Growing plants and animals are even more laborious and basically expensive, And suppose the plant cells you want to grow, we need to grow plant cells because they produce a lot of interesting metabolite, medicinal compounds, and so on and so forth, So this becomes very expensive, and very laborious, So you cannot do the trial and error method optimization which you are doing for the microorganisms. You have to do some kind of a statistical optimization for media and then modeling for design of the, I will say the quote unquote, the strategy says that they grow faster in minimum amount of time and give you the product which you can sell and make profit. And animal cells, as you know, they are very fragile and all that, so you have to be extra careful for this. So in the older time, people will just describe it, this is my bioreactor, vessel used to maintain ideal environment and so on and so forth. We can produce, we can do the cultivation in the submerged method and so this surface method. And basically, when the culture grows, is growth associated and non-growth associated. If this professor has to describe the different stages of the cultivation, he tells that you have a slant, it comes to the liquid solution, then it goes to the flask, and then it goes to the bioreactor. So that's about it, It can be made interactive. As I go around, you'll see that, Similarly, suppose animal cell propagation, somebody has to explain. You will say that we take out the kind of stock culture from the deep fridge, put it in the tea flask, put it in the CO2 incubator under like CO2 kind of blanket. The animal cells grow, and when they are grown, they go to the tea flask, and then you go to the bioreactor. Now there are different, like this is not enough. No, this is the chalk and talk philosophy. At the most, the slideshow, which is currently happening in the mode of instructions in the several universities, So this has to be changed so that the student get a interest in learning and all that. So that it should be better defined by the multimedia animations and all that, And instruction have to be given so that you do the minimum experiment. You don't have to do hundreds of bioreactor cultivation to optimize this. Just do the modeling and optimization of your kinetics of fermentation and design only one fermentation which gives the best product for you. So that tools we need to learn, So that is what I'll be telling you in the VLab, Similarly, I just give you a brief over the plant culture, how we do it, You have a plant, we make a callus, that goes to the suspension culture and then it goes to the bioreactor. We have to go to the bioreactor if you want to produce in kilos and all that, to sell the product, This is what happens. I'm giving example for A indica cells, This is like bean cells are there. They have the Directorate inside it. So you make the callus of it. That comes in the right media to produce a suspension culture. Then it goes to the bioreactor. You do the batch cultivation, fed batch and continuous. And these cultivations you have to design it intelligently so that you do the minimum. So this is all is there. I won't go into this thing. I'll just come back to this later on. Let me show you something, the lab thing, So I'll just, this is my VLab. Is it okay? Visible?
Visible, sir. You continue, sir.
Okay. So just you just type VLab IIT Delhi and you will reach here. Just click on this bioreactor modeling and simulation and you will get this lab. So here we have a lot of experiments, like just to teach you about the basics of the bioreactor, what it contains, how you do the batch cultivation, how you do the fed batch cultivation, continuous cultivation, how you produce the biopolymer, the anaerobic fermentation, how you do it propionic acid, how you do the plant cell batch cultivation, animal cell cultivation, even immobilization of the cell and so on and so forth. So very quickly I'll just go through it and you can just see how these are the theories are there. You just describe what are the different parts of the bioreactor. And the good thing is you have a video, which tells you about how the bioreactor is to be dressed, So that is what is very important. We have it for the two reactors. Okay, here. I'm just looking for the start of this, Yeah, it starts from here. Sorry about it.
But sir, why it is not coming?
So I'll just run through so that you can get an idea. Suppose this is the bioreactor, how to dress it up and how to do the fermentation, what are the steps. One by one, very slowly, by means of a video, it has been explained. So you can do it yourself, after you have seen this, So that is what is there. It's like reactor is being dressed up. You're calibrating the pH, calibrating the DO and all that. So we have the instruction for Applicon, dependable bioreactor and the bioengineering bioreactor. Two reactors I have selected and they are described over here, So this is how it goes and basically you set it up. Preparing the media and all that and so on and so forth. So you're just preparing the media ammonia, it goes to the bioreactor, and then you sterilize it and basically cool it down, so like that, So here again, you like the rest of the steps are there. I'll just go fast, so that we can have more coverage. This is what is there. The reactor is being now dressed up. Okay, I guess I stop there just to expose you that this is what is there. And then basically we have the questions, how much you have learned it. Bioreactor is used for this things, they multiply. Suppose you have a question, bioreactor is used for the cultivation. You are asked to give a choice. You select this, it says not this is the option is D. So that way, that's how the people learn it. And there are references, if you really go, there are a lot of references which you can go and refer about this particular topic. If you want to go to the next, this is the batch bioreactor cultivation. Again, everything is explained, how to dress up the reactor. There is a video also. I'll go fast in this, it's like you clean your laminar road, and then you basically do like this. You clean it, UV light, you sanitize your hand by alcohol, and then you take a slant, transfer it to another tube, which is liquid tube, so that they can grow. So that is what is being done. So you are taking a colony, it goes to the another liquid tube like this. The important thing to mention here is how you hold the plug. If you make a mistake here, then the contamination will blow up in the higher scale reactors like 5 liter. If you are going for industrial scale reactor, in 1 lakh liter reactor fermentation, and if the contamination comes there, that will be a disaster because they have to drain out the batch, and industries cannot afford to do that. So these tricks, you learn it, how you transfer it, where you have to hold the plug so that there is a contamination proof transfer and all that. And once you have transferred, it comes to the shaker, you just shake it, and then you want to transfer it to the flask. So you bring the tube where the culture is growing. Here you have the medium, and you transfer it. So like it goes. Again, the technique is how you hold the plugs and so on, how you do it near the plane and all. So that is easy to learn. So it's that's what is there, and then it goes the inoculum in the small 250 ml goes to 500 ml. So this is also tricky. The people have a tendency to put remove the plug and put it on the laminar root platform and all that. This is not to be done. See how the plugs are to be the plugs are to be kept in your both hands. Like this one plug has gone, you take another plug, and your plugs are in your hand, and then you transfer the liquid. So like that. So this is what is basically defined. Then you dress up the reactor, put it in the autoclave, and once it is autoclave, you connect it to the controller. So that's why it goes, so that's how it is there. Now autoclave is being autoclaved, like the reactor has been autoclaved and it is coming to the controller. So you just set it up with the different control units connected to the acid alkali pump and so on and so forth. So these kind of things are there. Here the culture is growing. Now you take the culture near to the reactor, transfer it into a blank autoclave flask near the flame, so that there is no contamination. It goes there, and slowly you transfer aseptically, and then by gravity it goes to the bioreactor. So like this, it goes to the bioreactor like so. And once it is gone there, it is up and running. You can take the sample and continue. So this is about the aerobic fermentation. Again, you have like self-evaluation and then references to lean on this further reading. Likewise, you have, am I audible? Hello?
Yes, sir. Yes, sir.
Yeah, I'm just checking, sometimes it goes off, so.
No,
okay.
No.
Okay. So like batch, fed batch, all the things are there. I will just tell you the estimate now. This is very specific, the development of the inoculum is very tricky. As you can see, here we grow from this, your that is very tricky, So you first of all you wash your laminar, wash your hands, and then you have the spores in the Hungate tube. That parent tube is there that you are transferring into the new media. So usually we take RCM media, take the spores from the parent slide and put it in the new tube like this, So it goes like this, and you have the spores in the fresh medium. So there, you put it in the anaerobic charge. Here, the cultivation has to be that the spores in the fresh media, this NN kind of labeled Hungate tubes, they will now go to the anaerobic jar. So it's like this. You have the anaerobic jar, wash it up, put your cotton there, put your samples of your inoculated fresh media with the spores, and then you put the gas pack. It's it produces hydrogen gas. You cut out this pack and put water into this and put it inside. When you put it inside, this start producing hydrogen gas, which basically uses the hydrogen which is present, and you have the anaerobic condition maintained. So here you grow the inoculum like this. Once the inoculum is grown in the your anaerobic jar, then it will go into the serum bottle like this. So serum bottle has to be made first of all. So basically we prepare the serum bottle is like injection bottle. You can see this is injection bottle. You have a rubber cap and then aluminum kind of a cap on it, and you seal it, So in this you prepare the medium. In the flask you have to cut out the neck and put the neck of the serum bottle, get it glass lowered over the top of the flask, and then you transfer this culture anaerobically. So that is how it goes. So first of all you will make it anaerobic. So you are just sealing the aluminum cap onto it so that you have aluminum cap on the serum bottle and the flask, and then you pass nitrogen, the filtered nitrogen, so that it becomes anaerobic. We have a resazurin dye which becomes pink, after it is anaerobic like this, So it is anaerobic, it is now anaerobic inside, So similarly we make anaerobic the flask, and then we transfer the growing inoculum into this, So that's the way it is. The growing inoculum was here, that goes into the serum bottle, So we transfer it like this, take the inoculum and aseptically it goes inside this. You see, it cannot be like transferred and just we are doing with the aerobic fermentation. It has to be from the syringe, like this, Take about 2% inoculum. We don't take high, in this, in the microbial culture we can go up to 5 to 6%, but here there is a risk of like products coming into the broth, so we take only 2%. That goes here, and then we put it in the incubator CO2 incubator, like this, So that's where basically your culture grows. You have not CO2, it's just the incubator. CO2 is in the animal cell, that will come later on. So you put a little kind of a filter outside. If there is production of gas, that will go out, But the culture is growing anaerobically. So this is what is there. Now when it is growing, this inoculum will go to the shake flask, like you see here, and then you put it in the incubator at a right temperature, 37 degrees a day, so the culture grows. And once it is grown, it goes to the reactor, as I have shown earlier, and it goes to the reactor like so, and then you just transfer the inoculum there. It is like inoculum is growing in the flask here. Take it out, it goes to the another flask like this one. Here it will go by the syringe, Remember one thing, when you are growing Clostridium, there is hydrogen gas production, so we cannot just open this near the flame, it may blast, So you take it from the syringe, and syringe say you inoculate it in this empty flask which has a little spout, and by gravity you transfer it in the bioreactor. So this is what is there. And then it starts growing, and you take the sample and basically do the analysis whether the culture is growing nicely or not, So this is about anaerobic fermentation. So we again stop here, go to the next one. What else? Like the plant cell, Plant cell is also very tricky, So plant cell batch cultivation, I show you. Again, theory and procedure. Then video is there, how you do the plant cell culture. So it is what, again, the laminar is there. Very quickly, I just go through it. So it's like you wash it, and then basically seeds you wash it, and it goes like this, and then the seeds you sterilize it by the sodium hypochlorite and your water, and then the seed goes into the flask. First of all, it goes in the seed goes into the your whatever medium, agar medium is there. You put the seeds here and the plant is produced. The way we can take the leaves from outside also, but it is difficult to develop the callus from here because there will be a lot of contaminants there. When you produce the plant like this, it is sterile. So you can take it directly and make the callus very easily. So that is how it goes. You just do like this, take the fresh leaves, cut it out, and then you basically put it in the media which is promoting the growth of the callus. So it goes there, and your callus, after you have just put it in the right media, the callus is grown, and then you basically bring the callus here and weigh it, definite amount of the callus is weighed, and then it goes to the liquid medium, and like this, so you're just transferring the weight amount of callus into the liquid medium. So that's what is going, and then it is there, and then you grow it in the shake flask, a small shake flask and big shake flask, and then it goes to the bioreactor. Like this, you have the shaker here, it goes going there, and it goes to the bioreactor as usual. You have seen it earlier also. So this is about how the plant cell is done. Very quickly, I just show you the animal cells, animal cell batch culture. Here we go to the video. So here the protocol is you have to just clean the laminar hood, wash your hands. Remember one thing, in animal cell media, we cannot sterilize it. It has to be filter sterilized, because it contains some vitamins like fetal calf serum and all that. If you really sterilize at 150 degrees centigrade, then your growth factors and vitamins will be basically deactivated. So you filter sterilize it. You filter sterilize like this, and like this is your parent culture in the tea flask. You have the parent culture in the tea flask, and you have the medium. You prepare the medium with glucose, glutamine. Usually 25 millimolar glucose we take and 5 millimolar glutamine we take, along with the fetal calf serum, 5% of that. So that you take in the sterilized tea flask, and then you transfer the this medium is the flask comes, sterilized flask comes, and then you prepare the medium, filter the side, and put the medium here, and then whatever parent culture is there, that goes here. How much amount of parent culture has to go here? That is by the count of the cell. You have to maintain a particular count. Usually when you have a culture growing like this, you have 10 to 9 to 10 cells, So you have to dilate to this to around 10 to 5 number of cells. So you have to count the cells. So we do it by the hemocytometer, how many cells are there, and accordingly decide how much inoculum has to be transferred. So that is what is there. And in order to find out the live and the dead cell, we use the Trifon blue, like this we do it, and basically you just find out the live and the dead cells, and basically live cells should be considered when you are doing the transfer, You do the hemocytometer, you might have just done it, and a lot of people, it's a very regular exercise, light and dark cells, and then you just transfer the right amount of cells there, and once it is up and growing in this tea flask, then it goes to the spinner flask, which is like this. You have the different stages of measuring this thing, and finally it goes to the spinner flask, which is here, So your culture which you have it is going into the spinner flask, Just go from the little beginning. You count the number of cells, and you again prepare the spinner flask, blank sterilize the flask, and basically blank sterilize the flask, and transfer the medium here. The way I told you, you have to prepare the medium, glucose, glutamine, and the fetal calf serum, and transfer the growing inoculum here. There are two arms in it, so that is what is there. You transfer your inoculum into this and put it in the CO2 incubator. Here you need 37 degrees centigrade and a blanket of 5% CO2, so the animal cell can grow. Without that they will not grow. So it will grow there, and once it is growing, then basically you again count the cell, whether the cells are grown or not. Once they are grown, then you basically transfer it in the flask and transfer it to the reactor, like we have done it for the earlier cases, and it goes to the bioreactor. It's up and running now. So this is how it is transferred here. Then you can take the sample, measure the biomass and live cells and the glucose, glutamine, and so on and so forth. So the point which I am trying to make by showing this, if you have a kind of a slide showing that these are the stages. You don't get a feel, that how this is done. This is like you're holding your hand, and just telling you that you have to do it so that you don't make a mistake. And this needs repetition, so the VLab can be used in that direction, to perfect the protocols and then basically do it in the right way. I don't want to go into a lot of things. You can just browse through. It's freely available. Just go to my site. I'll just give you the address also. If you don't remember VLab IIT Delhi and the Bioreactor Modeling and Simulation Lab, click that and you will be on to this. There is a kind of a mobilization kind of a method also, here. Let me very quickly show you, what it is. So you are making the calcium alginate beads. You are just washing hands and so on and so forth. The yeast is grown and you are preparing the cells, centrifuge it. So it tells you, what are the steps you have to do this immobilization process. These are the beads getting made, and then once the bead is ready, you load it into the reactor and pass the medium. Medium goes like this, and you are passing the substrate into the immobilized column, immobilized cell column, and out comes the product. You can really manipulate the feeding rate so that you have the high amount of product here, and then you do all kinds of calculations. So this is not only good for teaching, but it is also good for basically if you want to do it practically by yourself without going to the lab. So that is the additional advantage of these material which is available free of cost, to you. Now I switch gears. Now I introduce what is known as a little bit of modeling, because doing fermentation is not enough. You have to just study the kinetics and preferably prepare a mathematical model so that you can just simulate the model outside and design the cultivation strategy which gives you the highest amount of the product. The culture will be inhibited if you have high amount of substrate and high amount of product. So those things can come in the model. You simulate the model outside and design either the batch culture or the fed batch culture or the continuous culture by the model, and then go to the lab, just do one experiment to really demonstrate that you have the highest amount of the product form. So in this lab we have the simulator also. So if you really simulate, this is what is the model. Before this, I don't know how much time I have, and I'd love to show you what are the steps in the modeling, but well, okay, I'll just first of all tell you, most of you must be aware this is the specific growth rate. It is dependent on available substrate, so mu is dependent on substrate in a like a monad kind of a kinetics, and it is inhibited by the your high amount of your substrate present and product. So this is all captured in this. Okay, and like so, therefore, this is 1 by dx by dt. Dx by dt becomes this. Similarly, 1 by dx by dt is 1 by y mu plus m, and this mu is coming from here, so you have put it here. This is x, So dp by dt is defined as k1 times this mu plus k2. Growth associated product formation, which is k1 times mu. Mu is coming from here, and non-growth associated product formation. That is the k2 thing, So now you have the three things which is happening in the bioreactor. Let's see if I have the bioreactor here. Yeah, this is the bioreactor. Your substrate is present in this. Substrate is getting converted to biomass is growing, and the product and the product is also produced. So now these three equation defines that how, in what way. Suppose you have a different substrate concentration, different product in the bioreactor with different concentration of substrate in the bioreactor, how it will affect, and how the growth of the culture will be there for the, let us say, whatever bacteria you are using. So you have basically the knowledge of the model parameters like this, and essentially the whole thing is captured here. And this is essentially a first order nonlinear equation. You can solve it by the Runge-Kutta method. So in order to solve it, you need the initial condition. Let us say it is starting from 0 hour to 15 hour. You are basically trying to really see the cultivation from 0 to 15 hour in a time interval of 1 hour. All the model parameters, mu max has been calculated. I'll just describe you how it is done. to the best of my whatever time is available, I'll describe the different stages, and by that procedure you can find out the model parameter, and these parameters are written over here. There is a possibility you can change it, suppose your system model parameter is different, you can go and change, in start time of your cultivation and the stop time also you can change. The time interval between the two samples also, that is a possibility to change it, so these are the model parameters. These are the kind of interval of time you want to simulate the model. You want to see what happens from 0 to 15 hours in a time interval of 1 hour. So that is what is to be done. And these are the, once you have inoculated the reactor, the biomass concentration was 0.2 gram, substrate was 100 gram per liter, product was 0.2 gram per liter. So now you plug into this kind of a system, all the values are here, and then you say run simulation. So it does in the background in a flip of an eye, eyelid, and then you have it in front of you what it will look like. First of all, let's look at the table. Biomass was initially 0.2, it has grown to 3.199 by the model which you have taken in 15 hours. Substrate got consumed from 100 to 0.01. Product is increased from 0.2 to 99, and it's really interesting to know what is the dx by dt, ds by dt also, so that also is tabulated here for you, now, as I said, these are very important to figure out. Let's say you have got a product concentration of 99.28 grams. You take this data to your professor, he says, I want more product, you have taken 100 grams substrate, how about if we take 400 grams substrate, we should get four times the product formation. Okay, so you say, okay, I'll just tell you what will happen. You go here, and basically substrate concentration initial value was here, initial concentration was here, substrate concentration initially was 100 grams, you make it 400 grams. And run it again, and tell to your professor, this is what happens, look at this. Now you have started from 4S, only half, 1/3 of it is used, and it is after you have finished in 15 hours, 291 is left, Biomass is only 3.4, and product concentration has marginally increased, so it says that there is inhibition due to the high substrate you have taken, So a lot of kind of different substrate you can put in and get the answers right away. In the table, in the graph, and you can visually see what is happening. The substrate has 400, it has come here, it has not been consumed at 15 hours. So there is a need to really extrapolate this fermentation a little bit more. Let us do that, like end time, you make it as 30 hours, and let's run the model again, run simulation, and so it will simulate till 30 hours. Now you see, 30 hours everything is consumed, substrate is consumed, biomass is also produced. All the values tabulated here also. You can see here it has gone up to 30 hours and up to 0. So from 392 grams of your 400 grams of substrate, the product is coming 396 grams, which is pretty good, So the lesson is, if you have higher substrate concentration, you have to give more time for the cultivation, and that's what is there. If you are greedy, you say that, okay, now since I have got 400, let us go to 800 grams or some other. So you don't have to go to the lab to do the experiment. You just change the value here, instead of 400, let's say do it 600. Do the simulation again, it does. Probably it's not, model is not taking that, it's going in the loop, so that's not possible. 600 is not possible by this model, Okay, so this kind of model really helps you design your fermentation. You can just you can make it 50, 50 to 400 any value, and it will simulate for you. Say for example, when you did 50, it is consuming and very little biomass is produced. So you can say that 50 is very low a concentration. We have to go higher. And like that. I have showed you other values. The good thing is, once you have completed this, you can save it whole data in Excel, like you click this, save in Excel, and you go here. data is in front of you, time, biomass, and yeah, I suppose in the present time, all the students are familiar with this. They can use this and plot a nice graph to show it to their supervisor or to their employer and all that. So that is the kind of modeling thing. This is a very trivial modeling. When you learn it, you have to optimize the modeling, convert this into fed batch and things like that. In the model, in the VLab which I have, there is some problem in the other model, but I can show you elsewhere. I can show you here. Let's say this is your fed batch model. So here I have introduced the feeding term here. You are feeding fresh medium according to this term. The mass balance equation has changed. This is the batch, and then this is the fed batch. And the substrate term is also, this is the feed substrate. This is the substrate available at any point of time. So now you can just start feeding. Now here you have the model parameter. You are starting from 0 hour to 30 hour, and like biomass concentration is 0.2, 100 grams, 0.2 product, and 3 liter bioreactor is there. Now you can start at 6 hours. Let us say you have feed rate at 0.2, 15 hours 0.5. You can feed in that value and run the simulation. So it will just simulate it in front of you and show you what will happen. So here you have all the data in front of you, biomass, substrate and product, and volume is increasing. Now it is no longer 3 liter from 6 hours, as you can see here. You are adding fresh feed, and because of that, the product concentration has increased significantly. So this, which you would have been doing otherwise in the lab, you can do it by the model and figure out what is going to happen if I do this kind of a batch. And it tells you how much will be the final volume when you finish, and final product concentration. If you like it, do it in the lab, or better yet, there are other methods to design the unique fed batch fermentation which gives the highest biomass and the product consumption. That can be done, and you do that. So this is what is there. So likewise, there are several models are there. I just do it for the continuous culture. So it's all available here. Like this one. Here you have the dilution terms, and this is there. So here parameter you are putting at time this much hours and so on and so forth. It is there. Right now it is 0. But you can make whatever addition you want, dilution rate, whatever you want, you can put it here and simulate accordingly. And it tells you, it is, how much is your product concentration and how the dynamics is changing during the cultivation. So that is what is there. Some people might be using MATLAB, but there is not much possibility of visuals as you have it here. So that is what is there. And this is your model. In MATLAB, you have to just put in your model there, and that it will just only simulate it. In your exercise, you are developing the model. You know how you have developed it, and all the software and whatever else is required, these different optimization routines, they are known to you. MATLAB doesn't tell you, so therefore this is more powerful. Okay, so I just show you, let's say, another one. Plant cell cultures. I have just all the terms here. Growth rate is dependent on glucose, nitrogen, and phosphate, and it is inhibited also like this. Your alcohol, typical alcohol, Yeri-Salminsky type of model is there, and then the substrate is consumed due to the growth of the cell and due to the maintenance of the cell. It is for the glucose, this is for the nitrogen, this is for the phosphate, and this is the product formation. So when you just do this kind of thing, it is how this is how it looks like. Again, everything is in your slide, in your kind of front of you. You can change the different concentration of your input substrate and see what happens. You can do the batch, fed batch also, and like that. So similarly, there are complex model as well. Like propionic acid fermentation, and we have biopolymer production. Again, like mu is dependent on substrate concentration, and it is inhibited by the substrate concentration. You have carbon source, nitrogen source inhibited, and so on and so forth. So I'll just stop here. I hope you got a hang of what is this modeling and all that. So let me give you a little bit of introduction in whatever remaining time for how we develop the model. Okay, is it visible? I'm just coming to the stages in the model development. This is what is the mathematical model. There is like a way of description of your any kinetics, batch kinetics or fed batch kinetics. The biologists will do it their own way. Say for example, they have to describe the batch cultivation. So they will say that I have taken 20 grams of substrate is consumed. As the substrate was consumed, 2 grams of biomass produced in the end, and 0.5 gram of the product was found. That is what is his or her capability. You as an engineer or you as a biotechnologist can do better. You can just capture what is happening in the kind of a kinetics in terms of mathematical equation. The mathematical equations are simple, like you have seen, unstructured. When we say unstructured, biomass describes the activity of the cell, and easily, why we do that? It is easily verifiable. If you want to go a little more complicated modeling, then we have a structured model. You can incorporate intracellular component in the mathematical model in the growth equation, and then it becomes more realistic model. So generally we do unstructured because this is simple and very useful. Use of the mathematical model, you can understand the biological system, you have seen it. Once the model is ready, you can run it at different substrate concentration in a fraction of a second and see what happens to the cultivation. You don't have to go to the lab, do the experiment for 15 days to get the results. And another use of the model is to facilitate optimization so that the minimum experiment needed to strike a optimum. This is more important. That is where model is very helpful. So these are the steps in the modeling. First of all, you do the smoothing of the data point. By the way, this is listed in the my VLab, but very briefly. So it requires more input. So I'll just brief what is there, and then maybe if more interest is there, we'll just come back again for in-depth kind of a lecture. So smoothing of the data point you do. Then you propose the model, then you find out the model parameter, and then you find out the model parameter sensitivity. Let's say there are 6 parameters in the model: mu max, ks, km, k1, k2, etc. All the parameters may not be very sensitive. Let's say your mu max may be very sensitive. If you change the value of mu max by even 0.01, the simulation goes very crazy. The biomass is increased, product concentration goes down. On the contrary, the inhibition parameter, let's say the Ki or K, what are the inhibition, Ks inhibition, if you really change it by even 50%, there is hardly any change in the model parameter. So by this model parameter sensitivity analysis, we just, whatever parameters which are not sensitive, we just drop them so that the model become more robust. Lesser the model parameter, the model is more will have more predictive power, it's more robust. Once you have this thing established, then you find out the statistical validity of your model, and then the model is ready. These are the different steps. So okay, so the first step, this is your raw data point. What you see in the point, you have a raw data point. So we do the smoothing. So we essentially pass a curve like this, which is close to all data point, and the curve is as smooth as possible. We do it by the computer program, and you get a kind of a curve like this. So that is the first point. Then second part, we tabulate our result. You have the time versus the biomass, substrate, and product. Find out the rates, find out the specific rates, then plot the specific rates with respect to the different process variables. Suppose you plot mu versus S, you get a curve like this. So this is the approximate value of mu m. Why approximate? Because not only the growth, the product is also formed in the bioreactor, which is by the cell. So at least the approximate mu max you got it, and the Ks value you get it in here. So these becomes the starting value when you do the model parameter optimization. Then how the mu and p is changing? It is like exponential changing. It's never zero at a highest concentration of product. So kind of a like Ki upon Ki plus. Suppose it is becoming zero like this one, then you can fit this kind of model. When p becomes pm, the mu is becoming zero. So this kind of model will be fitted. So there are some guidelines of which model you have to select. If it is not become zero, then there is Ki upon Ki plus p. And if it is becoming zero, this is the Monod's model, mu is equal to mu max S plus Ks for this one. And the product concentration you add like this. This factor comes here. Similarly, the specific growth rate you find out from your raw data, plot it with respect to m, find out 1 by y and m. using this as the initial value, you will do the model nonlinear regression and find out the optimum value of 1 by y and m. Likewise, you plot 1 by x dp by dt versus 1 by x dx by dt mu, qp versus mu. Whatever is this, that is k1, and whatever this is there, that is k2. So you have the qp or 1 by x dx by dp by dt is equal to this thing, So this, these are the three equations. Your mu 1 by x dx by 1 by x dx by dt, 1 by x ds by dt, and 1 by x dp by dt, which is what you were seeing earlier. Now the question is, these parameters have to be optimized. So for that we do the non-linear regression analysis. This is how it looks like, model now. It looks like, I was telling you, if the product does not become zero, like it was here, you plot mu versus p, it does not become zero. So it's a good idea to really use this kind of inhibition term, And if you take high substrate concentration, that is study I have described here, take lower concentration, high substrate concentration, and so on and so forth, do the cultivation and find out mu versus s or mu versus p, and figure out whether it is becoming zero or it is becoming like this, Accordingly, you have to select this model or this model, And then this already you have seen earlier. So these are the mu, ks, and qp. So now we estimate the parameter. Remember, I told you the model parameters are only approximate. Now we do the nonlinear regression like this. We find out some of the squares of the weight residue. So for all data points 1 to n, and for all process variables, we found delta ij, and wj is the maximum value of any process variable, biomass, substrate, or product. So we divide it by this. When this number is minimum, then you have the right value of the model parameter. So that is what is done. Again, computer program is used, and we find out the minimum value of SSWR. This is what it is exactly. This is your curve, which is a smooth curve, is coming by the approximate value, and these are your experimental data. You have to minimize the difference, So when the model parameters are optimum, the parameters will lie exactly on the simulated curve, for all the three parameters. This is for the substrate, biomass, and the product, So that is what is the purpose of this parameter estimation or nonlinear regression exercise. So once you have this, you can go to the website which I have shown you, and basically run at it, and then you have all the simulations in front of you, and you can optimize the process. I only talked about the batch and little bit of at batch. There is a way by which you can find or extrapolate the batch model to fed batch model, and just shortlist or just come up with only single fermentation which is optimal, and nothing better can be done. Those are known as complex kind of little mathematical exercises, and the serious interested can get in touch with me, and basically we can discuss that. So my website address is this, my email is here, telephone, this is my current affiliation, all my publications are listed here. If you're interested in any one of them, then you can really get in touch with me. And this is my brief profile. I've been working for a year in your Giant Vitamins Limited, then I was in NCL, and then I came to HPTI, and then I was, since 91 I was in IIT till 2020, and from 21 I have joined NSUT Dwarka. Thank you very much.
Okay, sir. Thank you very much for your insightful lectures. I am Marcos Pandey on the behalf of Department of Biotechnology and Directorate of Research. A really heartfelt welcome to you and feel privileged. Sir, you have covered all those aspects starting from Director to use of virtual lab and requirement of virtual lab, and in Director you also cover plant, animal, and microbial culture. And this topic you covered, that virtual lab, is very interesting and very fruitful for faculty members as well as our students, and especially their beauty is that any place, any time, any place actually. This is the beauty, and we can revise again and again, do it again and again, and we'll learn more and more and benefited with the virtual lab. And these are the actually come under the quality teaching materials such as virtual lab and NPTEL. This is government initiative, and you have done a lot of work in this aspect. And sir, we have learned some hydrogen production concepts through your lecture, plant cell culture, animal cell propagation, immobilization of cells. In very short time, you have covered a lot of things, simulation and modeling, and structure and structure. People belongs to bioprocess background or study bioprocess definitely understand these things. And then again, you have show the importance of parameter estimation. And these are the very good lecture overall. And here some scholar working in the area of bioprocess development and you can enzyme technology. They will definitely benefited with your lecture. And if audience, if you have any questions, please ask. Sir is there. Question is open. Questioning session is open. Okay, I think everybody has understand all these things because it was very elaborative session. And thank you, sir. Thank you again. I feel very actually proud to be SBTIan. I have found my super senior, what a guru, mentor among in between us. And definitely we will invite you for physically for the lecture of our students, masters and PhD students.
Yeah.
And hopefully you will be available during
Yeah,
that
sure.
time.
Sure, I'll be there.
And thank you very much, sir.
So the purpose of this presentation was to expose what is available. Sometimes, as you said, I rightly said, plants and animal cells are ignored. But nowadays they are becoming important with the diseases coming in. Like you need novel drugs. And that is possible by plant and animal route. Find cell cultivation. We can't really look at the plant for huge supply of drug like Taxol. We need huge quantities, so that has to be grown in the bioreactor, and we cannot fool around. It has to be done in an optimized manner. So that process optimization is needed.
Very important.
Yeah, so that's what I thought, and I got a very good audience through you. I thought they are very young, curious minds. Let them expose with this.
Here some professors are also involved in this kind of research. Professor Mishra is here, and Dr. Piyush and Arpit is also working in this area. And some more faculties are here working in this. And definitely when you will come with here AKS University, you will brush up more actually our mindset and what is actually, and it is the now virtual lab is the importance for everybody and every student and every faculty, because all laboratories are not feasible for all laboratories to establish such kind of facilities over there. So it is very important and very good initiative. So, thank you, sir. Thank you very much.
Thank you so much for the invitation.
Thank you, sir. I think there is a Dr. Sachin Kumar sir is over here. Sachin sir.
Ashok sir, please kindly requesting you to please stop presenting. Click on the stop.
Sir, please stop your presenting.
Okay.
Now Dr. Sachin Kumar sir here with us from SSS Live, Kapurthala, Punjab. I would like to ask Arpit sir to kindly introduce him, and Sachin sir, are you here?
Yeah.
Hello sir. Good morning sir. Good morning sir.
Yeah, good morning.
We
Namaskar. I met you in IIT. Long back. So I am also an alumni of HBTI Kanpur.
that is a great moment.
PhD from IIT Roorkee, and now I am here in Kapurthala.
Okay, wonderful.
It's a MNRE's institute, Sadar Shwan Singh National Institute of Biology.
Okay.
So yeah. So that's it.
Thank you, sir, for joining us. I now Arpit, please welcome, sir, and over to you, Arpit.
Thank you so much, sir. So, with the next proceedings of this 1 week national workshop on RMCRT 2023. We are moving next with Dr. Sachin Kumar sir. We welcome you sir. Dr. Sachin Kumar is a Deputy Director in the Biochemical Conversion Division at the Sardar Savan Singh National Institute of Bioengineering Energy, Kapurthala, India. He was a visiting professor in the Department of Chemical and Biological Engineering at the South Dakota School of Mines and Technology, Rapid City, USA for a year. He obtained his PhD degree in chemical engineering from IIT Roorkee, India, and has research experience in biochemical conversion of biomass to biofuels, including bioethanol, biogas, biohydrogen, lignin, valorization, etc. He has completed 8 research projects and 1 consultancy project. Dr. Sachin has published more than 75 papers in peer-reviewed journals, book chapters, papers in conference proceedings, and 9 edited books. He had 1 granted US patent and 3 field Indian patents. He had delivered more than 52 invited plenary lectures and presented more than 75 papers in national and international conferences. He is a recipient of 2016 ASM IUSSTF Indo-US Research Professorship and selected as a Bioenergy Award for Cutting Edge Research BACER Fellow 2016 by DBT and IUSSTF. We welcome you sir, and now the stage is yours. Thank you so much.
Thank you very much for nice introduction. Okay, so nowadays we are mostly talking about renewable energy. Even government also promoting all kinds of renewable energy to replace the conventional one, which is basically come through the fossil fuels or like that. So let me share my screen first. Okay, so is it visible my screen?
Yes sir, you are good to go sir.
Okay, thank you. Okay, so any kind of renewable energy, whether it is solar, wind, hydro, biomass. So I mean, all renewable energy will have impact or their contribution to replace that conventional one. So now I will talk about mainly biomass energy, where biogas is one of the bioenergy resource that can be used to replace maybe like in cooking or kitchen you can replace LPG or maybe like LNG or in transportation as well you can replace CNG, which is mostly used in that NCR region or Delhi region like that. So in last budget also government has given a lot of emphasis to promote this biogas in our country. Okay, so from last maybe like 30-35 years, biogas has been used mainly in the households. I mean earlier, long back, maybe like 1980 or something, household based biogas plants were promoted in the country. Okay, but due to some technical issues or technical feedback was not there or technical support was not there, so most of the plants were not functional. But again, the emphasis has been given to this biogas, and now with with new designs or new process or like new feedstocks, they have been introduced to promote this biogas sector. At large scale mainly. So there was a need to develop the standards because we don't have any standards, so that stakeholders or developers can adopt it and can promote it in the country. So in last 2 years, we worked on these development of standards, and we have come out to this. And recently, I guess 15 or 20 days back, this standard is published by BIS, Bureau Indian of Indian Standards. Yeah. So this is the one. You can see the standard which we done: design, construction, installation, and operation of biogas, mainly biomethane plants. So this is basically code of practice. By adopting this standard, anyone can set up the plant, considering different feedstocks. So I will give the details of those feedstocks and other designs which are considered in this standard. So the scope is mainly, if you are going to set up a plant, you must have a design, and once you have design, then material of construction and where to install, how to install, what should be the size, and what feedstock you can use, and so that all these parameters have been considered in this standard. It also includes like classification of biogas plants. So based on the daily feeding or the availability of feedstock, you can classify. Based on that, how much biogas you will get per day basis. So based on that, the classification has been done. What feedstock should be included? Or
Second, sir?
Yeah.
Sir, there's a small request because we have certain UG students also. So we would like requesting you to be in Hindi language also, please.
Oh, अच्छा. Okay. कोई नहीं.
Thank you.
तो ओके, मैं कोशिश करता हूँ. कोशिश क्या, मैं तो हिंदी बोलता हूँ. ओके, ठीक है. तो यहाँ पे हमने बायोगैस प्लांट्स को क्लासिफिकेशन किया है बेस्ड ऑन कि हमारा डेली कितना बायोगैस प्रोडक्शन हो रहा है. ओके, और इसके लिए कौन कौन से फीड स्टॉक्स कंसीडर किए गए हैं बायोगैस के लिए, वो हमने इसमें डिफाइन किया है. देन व्हेन अगर कोई प्लांट चल रहा है बायोगैस का, तो उसमें उसकी परफॉर्मेंस हमें चेक करनी है. बेसिकली जो लास्ट हमने देखा कि कुछ बायोगैस प्लांट चलते चलते बंद हो जाते हैं, हमें रीज़न नहीं पता है कि क्यों बंद हो गए, और उनको कोई चेक नहीं करता है. तो टेक्निकल जो ग्लिच था, उसके लिए भी हमने इसमें चीज़ें रखी, क्या क्या परफॉर्मेंस पैरामीटर्स हमको मॉनिटर करने चाहिए ऑन डेली बेसिस, और व्हेन एवर यू फील कि हमारा बायोगैस प्रोडक्शन कम हो रहा है या कोई इशू है या बिल्कुल बंद हो गया है. ठीक है. अच्छा, इसमें जब हम बायोगैस प्लांट लगाते हैं तो डिफरेंट डिज़ाइंस होते हैं. जैसे सर ने अभी लास्ट प्रेजेंटेशन में बहुत सारे रिएक्टर डिज़ाइन और वो सब बताया, तो सेम चीज़ हम डिफरेंट डिज़ाइन ऑफ रिएक्टर्स कैन हैव टू सेट अप दिस बायोगैस प्लांट. ओके, तो वो डिज़ाइंस को भी हमने इसमें शो किया है. देन मटेरियल्स फॉर डाइजेस्टर्स, गैस होल्डर्स एंड देयर कंस्ट्रक्शन. और जो भी मटेरियल ऑफ कंस्ट्रक्शन रहता है, वो इसमें बेसिकली पहला पार्ट होता है जिसमें डाइजेस्टर मेनली रहेगा, जहाँ पे एनारोबिक डाइजेशन होता है. देन जो भी गैस बनती है, दैट वी हैव टू कलेक्ट इन गैस होल्डर्स. ओके, देन फर्दर प्रोसेसिंग होता है कि बायो सीएनजी बनाना है तो हमें प्यूरिफिकेशन करना है, क्योंकि इसमें CO2 रहता है, H2S रहता है, या और भी इम्प्योरिटीज हैं, तो वी हैव टू रिमूव देम फर्स्ट. ओके, देन और इसके अलावा भी और बहुत सारे इक्विपमेंट्स रहते हैं जो बायोगैस प्लांट में होते हैं. ओके, तो क्लासिफिकेशन जो हमने किया है, दैट इज स्मॉल स्केल, मीडियम स्केल एंड लार्ज स्केल बायोगैस प्लांट. अगर हमारा बायोगैस प्रोडक्शन 1 से 25 मीटर की 1 to 25 मीटर की पर डे है. हाँ, इसको रख दोगे. हाँ, स्मॉल स्केल के लिए 1 to 25 मीटर की पर डे, एंड देन मीडियम स्केल like 25 to 2500, लार्ज स्केल मोर देन 2500. सो अगर हम स्मॉल स्केल की बात करें, तो जैसे हाउस होल्ड्स में हमारा किचन वेस्ट जनरेट होता है, या हमारे पास बहुत सारे रूरल एरियाज में आप देखेंगे कि हम कैटल्स रखते हैं, काउज रखते हैं, बफेलोज रखते हैं. ओके, तो उनसे जो भी काउ डंग या कैटल डंग डेली जनरेट होता है, इंस्टेड ऑफ थ्रोइंग इट, और जैसे गाँव में उपले वगैरह बना के यूज़ करते हैं, दैट इज एक्चुअली उपले ठीक है, बट जो एफिशिएंसी है, जो हमें थर्मल एफिशिएंसी मिलनी चाहिए, वो उपले से उतना नहीं मिलता. अगर हम देखें कुक स्टोव से हमें हार्डली 10% एफिशिएंसी मिलती है। तो उसमें क्या होता है, हमारा पॉल्यूशन भी बहुत होता है, धुआं होता है, तो हाउस होल्ड्स में उससे बहुत ज़्यादा इश्यूज होते हैं। उसके लिए गवर्नमेंट ने और स्कीम चलाए थे कि हम हाउ टू इम्प्रूव द बायोमास कुकिंग स्टोव्स, तो वो भी एक अलग चीज़ है। बट काऊ डंग का एक डिफरेंट यूज है यहाँ पे, जो बायोगैस के लिए यूज होगा, तो वो हम स्मॉल स्केल लेवल पे हम कर सकते हैं। जैसे 1 मीटर क्यूब के लिए हार्डली 20 kg ऑफ काऊ डंग डेली रिक्वायर्ड है, तो 20 kg से हमें 2 बफेलो या 2 काउज से हमें मिल सकता है। ओके, अगर हमारे पास 2 है तो हम एक 1 मीटर क्यूब का बायोगैस प्लांट लगा सकते हैं। अगर इससे ज़्यादा है, अकॉर्डिंगली वी कैन इंक्रीज द साइज। और जो डेली बायोगैस प्रोडक्शन होता है उसको हम हाउस होल्ड्स में इवन डायरेक्टली हम कुकिंग स्टोव्स में फीड करके उसको यूज कर सकते हैं। बट इसके जो कुकिंग स्टोव्स होते हैं वो डिफरेंट होते हैं, जो कि मार्केट में अवेलेबल है। ऐसे ही अगर जैसे कम्युनिटी लेवल पे जाएं या कुछ डेयरीज रहते हैं, काऊ डेयरीज, वहाँ पे तो नंबर ऑफ कैटल्स आपके ज़्यादा होंगे, तो उसके हिसाब से आप आई मीन किस स्केल पे आपका ये आएगा बायोगैस प्लांट, वो आप चूज कर सकते हैं। अगर मैं बात करूं 1 kg ऑफ काऊ डंग की, तो दैट विल गिव यू अराउंड 40 मीटर क्यूब ऑफ बायोगैस, दैट इज द मैक्सिमम वन। देन मीडियम स्केल, अगर आप जैसे फार्म वेस्ट है या एग्रीकल्चरल रेजिड्यू कुछ है या और कुछ इस तरीके का वेस्ट है, तो एक मीडियम स्केल पे भी हम जा सकते हैं। ठीक है, मीडियम एंड लार्ज स्केल वी ऑलवेज थिंक ऑफ प्रॉफिटेबल बिजनेस। ओके, मीन्स वी कैन अर्न सम मनी आउट ऑफ इट। तो उसमें हमें फर्स्ट कंसर्न इज टू हैव दैट अमाउंट ऑफ फीड स्टॉक ऑन डेली बेसिस। तो उसके बेसिस पे हम आई मीन किस स्केल का प्लांट हमें लगाना है वो हम सेलेक्ट करते हैं। देन फिर हम सोचते हैं कि हम इसका एप्लीकेशन क्या रहेगा। इफ यू आर नियर बाई सम इंडस्ट्री वेयर दैट बायोगैस यू कैन सेल, एंड that is okay. Otherwise you can nowadays IOCL and other companies are buying bio CNG. Bio CNG आप प्रोड्यूस कर सकते हैं। एक है LNG, I mean LNG or PNG is it? Yeah, PNG you can use, I mean you can feed that gas in PNG lines, so you can replace CNG directly। ठीक है, note guys, small scale biogas plants for largely urban and semi-urban areas for digesting domestic kitchen waste. Okay, अगर जैसे अर्बन एरियाज में किचन एंड गार्डन वेस्ट रहता है, जो कि क्वांटिटी कम हो सकती है, तो हम छोटा एक प्लांट भी लगा सकते हैं, इवन 1/2 मीटर क्यूब पर डे का भी प्लांट लगा सकते हैं। ठीक है, okay, so what are the feed stocks that are considered? That should be like organic waste from animal. So I was talking about like mostly in rural areas you will find that organic waste. Biodegradable solid and liquid organic waste from industries including sugar mills, food processing industries, then crop residues and suitable stubbles. अगर हम स्टबल की बात करें लाइक पैडी स्ट्रॉ एंड अदर वेस्ट, सो मेनली नॉर्दर्न इंडिया लाइक पंजाब, हरियाणा, यूपी, तो यहाँ पे जो पैडी स्ट्रॉ है जिसको हम पराली बोलते हैं, उसको हम खेतों में जला देते हैं। इसका रीज़न है क्योंकि इसका नॉर्दर्न इंडिया में बेसिकली ये एज ए पाउडर नहीं यूज होता है, तो इसका कोई और अल्टरनेटिव एप्लीकेशन नहीं है। तो इंस्टेड ऑफ कलेक्टिंग ये जो पराली को कलेक्ट करने की बजाय उसको जला के तुरंत इसको इसका आई मीन डिस्पोज ऑफ कर देते हैं, जो कि ठीक नहीं है। इससे पॉल्यूशन होता है, आपका जो आई मीन लैंड और सॉइल में जितने भी माइक्रोब्स या मिनरल्स होते हैं दैट आल्सो डैमेज। तो हमें इस प्रैक्टिस को रोकने के लिए हमें इसका एप्लीकेशन ढूंढना है। तो ये बायोगैस प्रोडक्शन कैन बी वन ऑफ द ऑप्शंस। ऑर्गेनिक बायोडिग्रेडेबल फ्रैक्शन ऑफ म्यूनिसिपल सॉलिड वेस्ट, आप देखते हैं MSW पूरा जो इवन नाउअडेज जो टाउन्स है ना, उनके बाहर भी आपको ये एकदम हीप्स मिल जाएंगे। तो इसका एक अच्छा एप्लीकेशन है बायोगैस प्रोडक्शन में। डोमेस्टिक सीवेज, जो सीवेज होता है जनरली जो म्यूनिसिपैलिटीज होती हैं वो STP प्लांट चलाते हैं, तो वहाँ बेसिकली USB और ये डिफरेंट टाइप के डिज़ाइंस अडॉप्ट किए हुए हैं जहाँ मेनली बायोगैस बनता है। अच्छा, जो फीड स्टॉक्स इंक्लूडेड नहीं हैं, दे आर लाइक फॉसिल फ्यूल्स एंड प्रोडक्ट्स एंड बाई प्रोडक्ट्स मेड फ्रॉम them, woody biomass, papers, cardboard, pasteboard, harbor sludge and other water body sludges, plastics, metals and biomedical or pathogenic waste. So they are basically recyclable or can be used some different applications. So ये जो फीड स्टॉक्स हैं ये बायोगैस प्रोडक्शन के लिए सुटेबल नहीं है. Okay, then based on different scales or for different ways, हम लोगों ने सेट किया कि कितना मिनिमम OLR होना चाहिए, HRT एट द मैक्स कितना होना चाहिए, volatile solids remove in percentage कितना होना चाहिए अल्टीमेटली, एंड स्पेसिफिक बायोगैस प्रोडक्शन कितना होना चाहिए पर kg ऑफ volatile solid removed, मिनिमम बायोगैस प्रोड्यूस पर टन ऑफ सॉलिड वेस्ट. तो ये जो भी पैरामीटर्स हैं दैट इज कैप्ड एट मिनिमम लेवल. तो कोई भी अगर आपको टेक्नोलॉजी देता है और उसमें क्लेम करता है तो एटलीस्ट इससे इस टेबल के अकॉर्डिंग हमें चेक करना होगा. जो फीड स्टॉक्स या वेस्ट मटेरियल जो कंसीडर्ड हैं लाइक पोल्ट्री वेस्ट, म्यूनिसिपल सॉलिड वेस्ट, फूड वेस्ट, वेजिटेबल वेस्ट, स्लॉटर हाउस वेस्ट, देन एग्रीकल्चरल वेस्ट, किचन वेस्ट, कैटल डंग, सी वेस्ट स्लज. बेसिकली ये जितने भी फीड स्टॉक्स हैं इनके लिए हमें सीड या इनोकुलम भी चाहिए. तो दैट इनोकुलम में भी लाइक एसटीपी स्लज, काउ डंग और कैटल डंग, recirculated slurry or any other microbial inoculum which is present in the water that can be used. Okay, then OLR varies from high rate to low rate to standard rate energization, like for high rate like 4 to 8, standard rate 2 to 4, low rate 1 to 2. HRT also varies, and as less than 15 days that will be considered like a high rate, and if it is 15 days to 25 days that will come under standard rate, and if it is more than 25 days that will be low rate digesters. And units and parameters above and recommended for optimum performance, and improved parameters or improved performance is desirable. And for reference, it may be assumed that for a family of 4 persons, 1 meter cube per day biogas production is required for cooking purposes. Okay, so if we select any feedstock, so before that we need to characterize it, and or we should know the characteristics of that feedstock. Or I mean, if there is a deviation, then you have to maintain. So that maintenance can be done. जो हम मेंटेन करेंगे जो भी ये पैरामीटर्स हैं उसमें हम कोडाइजेशन कर सकते हैं. कोडाइजेशन मीन्स कि अगर हम बात करें जैसे एग्रीकल्चरल वेस्ट की, उसमें कार्बन बहुत ज़्यादा होता है, नाइट्रोजन बहुत कम होगा. तो C/N रेशियो अगर हम देखें तो वो बहुत ज़्यादा होगा, मे बी लाइक 70, 75 और इवन मोर देन दैट. तो हम उसमें जैसे यहाँ एक पैरामीटर है C/N रेशियो जो कि हमें 15 से 15 to 30 रखना है. ओके, तो अगर हमारा C/N रेशियो किसी एग्रीकल्चरल वेस्ट में मोर देन 75 है तो हम क्या करेंगे, उसमें ऐसा कोई फीड स्टॉक मिक्स करेंगे जिसका C/N रेशियो बहुत कम है. आई मीन कार्बन कम है, नाइट्रोजन ज़्यादा है. मे बी लाइक एनी प्रोटीनियस फीड स्टॉक या फूड वेस्ट, किचन वेस्ट. तो ये जितने होते हैं इनमें प्रोटीन्स वगैरह ज़्यादा होते हैं, तो नाइट्रोजन कंटेंट ज़्यादा है. अगर हम इसको कोडाइजेशन मीन्स 2 सबस्ट्रेट को या 2 फीड स्टॉक्स को मिक्स करके हम एनारोबिक डाइजेस्ट करते हैं. ओके, अब आता है टोटल सॉलिड्स. तो सॉलिड्स जब हम कोई भी डाइजेशन या फर्मेंटेशन करते हैं तो सबस्ट्रेट concentration or in case of this feed stocks we consider total solid in percentage. So that should be optimized first. So if we keep like 5 to 15, so that उसको हम bad digestion बोलेंगे. और अगर हम 15% से ज़्यादा रख रहे हैं तो हम उसको dry digestion बोलेंगे. Then बायोगैस प्रोडक्शन में वॉलेटाइल सॉलिड्स का बहुत इंपॉर्टेंस है, लाइक दैट शुड बी मोर देन 60%. particle size. हेलो, हाँ मैं एक प्रेजेंटेशन दे रहा हूँ, मैं बात करता हूँ. ओके, पार्टिकल साइज लाइक अगर हम जैसे स्ट्रॉ की बात करें या कोई एग्रीकल्चरल रेसिड्यू है, उस स्ट्रॉ की लेंथ बहुत ज़्यादा है तो उसको डाइजेशन में बहुत ज़्यादा टाइम लगेगा. तो हम क्या करेंगे, उसका साइज रिड्यूस करेंगे. साइज रिड्यूस करने से क्या होता है, सरफेस एरिया, स्पेसिफिक सरफेस एरिया विल इंक्रीज. ओके, तो जो भी माइक्रोबियल या एंजाइमेटिक एक्टिविटी है दैट विल इंक्रीज, दिस इंटरेक्शन विल बी मोर. ओके, तो ये भी दैट शुड बी अकॉर्डिंग टू द टेक्नोलॉजी और जो भी प्रोसेस आप यूज कर रहे हैं उसके अकॉर्डिंग आपको पार्टिकल साइज रखना है. ओके, नाउ अगर कोई डाइजेस्टर आपका चल रहा है, एनारोबिक डाइजेशन चल रहा है, तो हमें उसमें कौन कौन से पैरामीटर्स चेक करने हैं. फर्स्ट, टेम्परेचर. अगर हम देखें काउ डंग के साथ अगर हम कोई डाइजेशन करते हैं तो दैट शुड बी एट आई मीन ऑप्टिमम टेम्परेचर इज 37 डिग्री सेंटीग्रेड. थोड़ा ऊपर जा सकता है लाइक अप टू 40 और बिलो लाइक 20. अगर हम 20 से नीचे जाते हैं तो आपको कोई बायोगैस प्रोडक्शन नहीं मिलेगा. तो जो मीजोफिलिक रेंज है दैट शुड बी 20 to 40. एंड देन अगर आपका कोई कंसोर्शियम थर्मोफिलिक है तो वहाँ पे आपका 45 से 60 डिग्री टेम्परेचर रह सकता है. सिमिलरली पीएच, एक्चुअली बायोगैस प्रोडक्शन में पीएच का बहुत बड़ा रोल रहता है. अगर आपका पीएच डाउन गया, बिलो 7 गया, तो आपको मीथेन तो नहीं मिलेगी, लेकिन हाँ आपको हाइड्रोजन मिल सकता है. दैट डिपेंड्स ऑन द फीडस्टॉक और आपका जो कंसोर्शियम है वो क्या है, उसके बेसिस पे ये डिपेंड करता है. तो हमें पीएच को भी मेंटेन करके रखना है. अगर जैसे कम या ज़्यादा हो रहा है तो यू हैव टू मेंटेन इट. एक और होता है फॉस्टैग रेशियो. फॉस्टैग रेशियो बेसिकली आपका इसमें एक तो बीएफएस बनते हैं और आपका एक कुछ ये अमोनिया या एल्कलाइन फॉर्मेशन भी होता है. तो उसका जो रेशियो है अगर वो 0.3 to 0.4 के बीच में है, दैट मीन्स कि योर डाइजेशन इज हेल्दी. ओके, सो अगर हम देखें फास्टैग का रेशियो का क्या है, तो दैट इज द इंडिकेटर फॉर असेसिंग फर्मेंटेशन प्रोसेस. टैग वैल्यू इज एन एस्टिमेशन ऑफ बफर कैपेसिटी ऑफ सैंपल एंड कॉस्ट वैल्यू correspond to volatile fatty acid content. Okay, so I mean in next table I will show. So if that value increases like 0.3 to 0.4 is the optimum. अगर आपकी ये जो फास्टैग वैल्यू है 0.6 से ज़्यादा है, इट मीन्स कि आपने बायोमास और जो फीड स्टॉक का इनपुट है वो बहुत ज़्यादा है या ऑर्गेनिक लोडिंग रेट बहुत ज़्यादा है, आपको तुरंत उसको स्टॉप करना है. अगर फास्टैग रेशियो आपका 0.5 to 0.6 है तो भी आपका बायोमास इनपुट ज़्यादा है, तो हमें बायोमास फीडिंग रिड्यूस करना है. अगर 0.4 to 0.5 है तो प्लांट इज हैवीली लोडेड, मॉनिटर द प्लांट मोर क्लोजली. आई मीन जो फीड है उसको कम ज़्यादा करके देखना है. और अगर 0.3 to 0.4 है, यू विल गेट मैक्सिमम बायोगैस प्रोडक्शन. अगर डाउन जा रहा है मीन्स 0.2 to 0.3 है तो बायोमास इनपुट इज वेरी लो, तो आपको बायोमास इनपुट और फीड स्टॉक इनपुट इंक्रीज करना है. सिमिलरली अगर आपका 0.2 से नीचे है तो आपका बायोमास इनपुट बहुत ज़्यादा लो है, तो आपको तुरंत बायोमास लोडिंग इंक्रीज करना है. ओके, डिफरेंट डिजाइंस ऑफ बायोगैस प्लांट्स. तो जैसे हमने 3 कैटेगरी बनाए थे, स्मॉल, मीडियम एंड लार्ज. स्मॉल स्केल के जो बायोगैस प्लांट्स हैं दे आर लाइक CSTR1, that may be like horizontal or vertical design. There may be floating drum plant, that is basically KVIC model. Floating drum plant with a hemisphere digester, that is Pragati model. Floating drum plant made of angular steel and plastic foil, that is Ganesh model. Again, floating drum plant made of prefabricated reinforced concrete compounds. A floating drum plant made of fiberglass reinforced polyester. A fixed dome plant with a brick reinforced modular dome, that is Janta model, for 6 to 25 meter cube per day. Similarly, Deen-1-2 model, that is up to 6 meter cube, and there are some bag type digesters. And in small and large, mostly designs are common, like that may be USB, CSTR, external circulation sludge bed, a plug flow reactor, BIMA digester, high rate solid digester, fixed film reactors, and there is another that is particularly for medium scale, that is modified PAU Janta model, that is up to 500 meter cube per day, and floating film reactors. So these are the designs can be, these designs are considered for the biogas plants. Then come to the material of construction. So in that last slide I showed the design. So based on that design, we have to select the material of construction. So like mainly for small scale plants, we can use masonry, brick work basically, brick or concrete work can be used. So there are already standards available, that is IS 1905. So all the details you will find there and can adopt for this masonry work. Then you can use RCC, reinforced concrete cement. So like for starting from small to like large scale biogas plants, you can use RCC. So this standard is available for them. Then steel, that may be like mild steel. So that IS 800 is available. Then high density polyethylene, so that is called HDPE. So this is basically for small scale biogas plants. Then linear low density polyethylene, that is again called LLDPE. Then ferrocement, FRP like glass fiber reinforced plastics, high quality polypropylene sheet, PVC line polyester double UV coated fabric, polyethylene with polypropylene or EPDM, that is ethylene propylene diene monomer. So that is basically used in the bag type biodigester. So these are the material can be used to fabricate the digesters. Then what material can be used for gas holders? So gas holders, that may be like a big balloons can be used. So that may be the material may be this linear low density polyethylene LLDPE, or some brick masonry work can be used where you can use the floating drum and you can collect the gas. Another like glass fiber reinforced polyester resin with steel frame, that can also be used. PVC double UV coated fabric can be used, and steel one also can be used. And this is a calculation to calculate the gas holder volume. So that is based on the per day biogas production, and then for how long you want to store it. Because based on your application, you have to select the duration of storage. So basically, if you are doing like bio-CNG production, so at least 3 hours storage should be there. Okay, then there are some membrane-based biogas holders also. So these are the specifications, like how much should be the tensile strength, gas diffusivity, temperature resistance, then surface resistance, bleeder resistance, UV resistance, flame resistance, and then maximum operating pressure. Okay, so once you have set up the plant, then you should have the pipes and fittings to, that is mainly to transfer the gas, or once it is once you have the purified one, then you have to transfer it in the gas cage or something. That should be considered. So the pipes carrying biogas shall be either made of SS304 or above. Polyethylene, that is this is standard, then HDPE, then polypropylene, polycarbonate, etc. Then pipe shall be corrosion resistant to the feedstock and biogas, because once you get the biogas, there will be moisture, there will be H2S and other contaminant. So they mainly moisture and H2S, they are basically corrosive one. So the pipelines which you want to use for biogas transfer, that should be corrosion resistant. Then the pipe shall be distinct for feedstock and biogas and shall be coated with canary yellow. So for these flammable gases, we generally use this canary yellow kind of color. Right? Then within the plant, before purification unit, the pipes and fittings are to be of SS, and after purification of biogas, it may be transported using pipes and fittings being used for natural gas. So that should be as per this standard. Then however, small biogas plants may also use STP, CPVC, and then fittings instead of SS. So that is based on basically you are going for small scale or medium or large. So accordingly you can decide it. And all piping material shall have appropriate corrosion allowance and UV tolerance for design life of minimum 15 years. Then okay. So if you are going to set up a plant, then you should consider the feedstock availability by 365 days. So based on you have some feeding per day. So per day, that feedstock should be available readily. So some feedstocks, like if I talk about like paddy straw. So paddy straw is available for 2 to 3 months only. But you have to run your plant throughout the year. Okay, that may be like 300, 330 days or maybe 360 days. Okay, so that feedstock should be available through all the days. Okay, then you have to make the storage. So now in some feedstocks, like if you work on MSW, so MSW you can get, daily you can get from the municipality. So for some days, for some hours, so like that, you have to select based on your feedstock how much storage would be required. So like for short-term storage of feedstock, appropriate facility for leachate collection and covered storage without causing odor problems will be designed and set up at the site for biogas plant. So this is basically for MSW. Okay, for long-term storage of feedstock, the facility shall follow central CPCB rules or state pollution control board rules. Then if feedstocks are liquid, then the feedstock slurry may be stored in appropriate leak-proof tanks before adding it to the digester as applicable. Okay, then if you see the different applications of biogas, so CNG is one of the options which is being used in the transportation where you can replace the CNG one. Okay, so these are the specifications, that is as per the standard AS standard 16087. Like bio CNG sampling, so this is the standard we have to follow. Then how much should be the methane content? Minimum there should be 90% and maximum that may be like up to 100 also. So this is the standard for testing, and we can use gas chromatograph. Then moisture maximum should be 5 ppm or 5 milligram per meter cube. और टेस्ट मेथड आपका ये है. देन हम इसको कार्ल फिशर टाइट्रेटर से इसको मॉइस्चर चेक कर सकते हैं. देन टोटल सल्फर इंक्लूडिंग H2S एंड इन अदर फॉर्म्स ऑल्सो, उसमें 20 ppm और मिलीग्राम पर मीटर क्यूब मैक्सिमम होना चाहिए. और उसका डिटर्मिनेशन के लिए हम टेंशियोमेट्री से हम इसको एनालाइज कर सकते हैं. And other gases like CO2, N2, oxygen, that should be maximum 10%. Okay, वो भी हम गैस क्रोमेटोग्राफी से एनालाइज कर सकते हैं, जिसमें CO2 मैक्सिमम 4% होना चाहिए. Then O2 मैक्सिमम 0.5%. तो अगर आपको बायो CNG की तरह इसको सेल करना है मार्केट में, then ये स्पेसिफिकेशन आपके फॉलो होने चाहिए. अगर आपको कुकिंग में यूज करना है हाउस होल्ड्स में, तो इसके लिए स्टैंडर्ड अवेलेबल है, दैट इज 87 49 इसको फॉलो करना है। हाँ, बायोगैस को इलेक्ट्रिसिटी जनरेशन में भी यूज कर सकता है। मार्केट में 100% बायोगैस बेस्ड इंजिन्स अवेलेबल है। जैसे सीएनजी बेस्ड इंजिन रहता है वैसे ही बायोगैस के लिए भी है, जहाँ पे अगर रॉ बायोगैस भी है, लाइक रॉ बायोगैस मेनली 55 to 60% और 65% मीथेन रहता है। ओके, तो आप डायरेक्टली उसमें फीड कर सकते हैं और इलेक्ट्रिसिटी जनरेट कर सकते हैं। सिमिलरली अगर आप प्यूरिफिकेशन की बात करते हैं तो लाइक इफ 90% इज देयर देन आपका एफिशिएंसी बढ़ जाएगा। ओके, अच्छा इसके बाद आता है अगर हमारा एनारोबिक डाइजेशन हो गया, इसके बाद जो भी डाइजेस्टेड बचेगा उसको भी हम यूज कर सकते हैं एज ए बायो फर्टिलाइजर। ओके, ये जो बायो फर्टिलाइजर की स्टैंडर्ड्स भी अवेलेबल है, दैट इज फ्रॉम एफसीओ, जिसमें कि अभी रिसेंट अमेंडमेंट हुआ था 2020 में, जिसमें मॉइस्चर कंटेंट को इंक्रीज किया था, दैट शुड बी लाइक 30 to 40%। ओके, और 2021 में एक और अमेंडमेंट आया जिसमें कि लिक्विड स्लरी को भी आप यूज कर सकते हैं, जहाँ पे 90 to 97% लिक्विड होना चाहिए, और इन अदर टर्म्स सॉलिड शुड बी 3 to 10%। ओके, बाकी पार्टिकल साइज, टोटल ऑर्गेनिक कार्बन लाइक 14%, एनपीके, बेसिकली फर्टिलाइजर में एनपीके का रोल बहुत इंपॉर्टेंट रहता है। तो ये अगर कम भी है तो हम इसको कुछ नेचुरल रिसोर्सेज से इसको ब्लेंड करके मेंटेन कर सकते हैं, एंड देन वी कैन सेल इन द मार्केट। C/N रेशियो, pH, कंडक्टिविटी, एंड दैट शुड बी पैथोजन फ्री। कुछ हैवी मेटल्स भी रहते हैं, दैट डिपेंड्स बेसिकली ऑन द फीड स्टॉक, और जो वाटर हम यूज करेंगे डाइजेशन के ड्यूरेशन में, तो वहाँ पे अगर हैवी मेटल्स बहुत ज़्यादा हैं तो उसके रिस्ट्रिक्शन के लिए इसमें रखा गया है। तो ये मैक्सिमम लेवल दिया हुआ है ये हैवी मेटल्स। अच्छा, जो भी हमारा फर्टिलाइजर है फर्दर अपग्रेड कर सकते हैं, जिसको हम प्रॉम बोलते हैं, पोटेशियम फॉस्फेट रिच ऑर्गेनिक मैन्योर, और माइक्रोबियल इनोकुलेंट एंड रिच सॉलिड लिक्विड बायो फर्टिलाइजर। नेक्स्ट स्लाइड में मैं दिखाता हूँ। Prom, this can be prepared by mixing solid manure fraction with fine powder of rock phosphate. So जैसे rock phosphate हमने mix किया with minimum of 8% like P2O5 and 10% of organic carbon, उससे हम prom तैयार कर सकते हैं। Ratio of each ingredient can be worked out after analysis of all ingredients and standardizing to achieve the desired value. अगर हमें ऑर्गेनिक मैन्योर कंटेनिंग 3% न्यूट्रिएंट्स, तो ये हम अगेन रॉक फॉस्फेट या नीम केक, कैस्टर केक, ये सब मिक्स करके हम एनपीके की रिक्वायरमेंट को बढ़ा सकते हैं अप टू लाइक 3%। ओके, अगर आपका प्लांट चल रहा है तो हमें क्या क्या सैम्पलिंग करनी है, क्या क्या एनालिसिस करने हैं। तो जैसे हमें पहले फीड स्टॉक का एनालिसिस करना है, जिसमें टोटल सॉलिड हमें पता होना चाहिए, देन वोलेटाइल सॉलिड्स। तो ये मेथड्स ऑलरेडी अवेलेबल है, लाइक ASTM मेथड है, या BIS के भी स्टैंडर्ड्स अवेलेबल है, मेथड्स हैं जिसको हम यूज करके ये सब BSTS हम निकाल सकते हैं। कंपोजिशनल एनालिसिस, जैसे कोई भी वेस्ट है तो अगर हम देखेंगे फर्मेंटेशन किसका होता है, मे बी लाइक ग्लूकोज हो, या जैसे मोनोसैकेराइड्स कोई भी हैं, या डाइसैकेराइड्स, या पॉलीसैकेराइड्स आर देयर। तो जो फीड जो मोनोसैकेराइड्स होते हैं उनको तो हम लॉन्ग टर्म के लिए नहीं रख सकते, वो बहुत जल्दी जैसे किसी इंडस्ट्री से भी इफ्लुएंट वगैरह में निकलता है तो उसको वहीं पे ट्रीटमेंट करके इफ्लुएंट को थ्रो करते हैं। बट ये जो हम वेस्ट देख रहे हैं, जैसे MSW हो गया, या एग्रीकल्चरल वेस्ट हो गया, या काउ डंग हो गया, तो इनमें जनरली जो कार्बन है वो पॉलीमेरिक फॉर्म में है। तो हमें पहले कंपोजिशन उसका पता होना चाहिए। जैसे अगर हम एग्रीकल्चरल वेस्ट की बात करते हैं तो उसमें सेलुलोज है, हेमीसेलुलोज है ना, लिग्निन भी है, बट लिग्निन से हम बायोगैस नहीं बना सकते क्योंकि उसका स्ट्रक्चर डिफरेंट रहता है। ठीक है, तो हमें कंपोजिशन भी पता होना चाहिए, उसके बेस पे हम कैलकुलेट भी कर सकते हैं कि इससे कितना बायोगैस बनेगा। देन सी बाई एन रेशियो हमें मेंटेन करना है या हमें पहले चेक भी करना पड़ेगा, देन हम डिसाइड करेंगे कि हमें प्योर फीड स्टॉक रखना है या को डाइजेशन करना है। अच्छा, पीएमपी एनालिसिस दैट इज बायोकेमिकल मीथेन पोटेंशियल, तो ये हम लैब में कर सकते हैं कोई भी फीड स्टॉक लेके काउ डंग के साथ में या किसी और इनोकुलम के साथ में आप यू हैव टू इनोकुलेट इट एंड जो भी एनारोबिक डाइजेशन हो रहा है उसका रीडिंग्स रिकॉर्ड करना है कि कितना बायोगैस बन रहा है, उसमें कितना मीथेन है एंड कितने दिन तक वो बना, तो वो सारे पैरामीटर्स हम इसमें चेक कर सकते हैं। प्रोडक्ट या प्रोसेस में हमें पीएच का मेजरमेंट करना है, फॉस्टर रेशियो, बायोगैस यील्ड, बायोगैस एनालिसिस एंड डाइजेस्टेड स्लरी जो भी आएगा देन उसका एनालिसिस करना है कि हम उसको बायो फर्टिलाइजर की एप्लीकेशन के लिए यूज करें। ओके, सो ये पैरामीटर है जो डाइजेस्टेड स्लरी के लिए यूज होते हैं, लाइक सैम्पलिंग, ये मेथड्स है, टेस्ट मेथड्स अवेलेबल। तो हमें मॉइस्चर चेक करना है, देन कलर भी देखना है, ऑर्डर देखना है, पार्टिकल साइज, बल्क डेंसिटी, टोटल ऑर्गेनिक कार्बन, टोटल नाइट्रोजन, टोटल फॉस्फेट, टोटल पोटेशियम एंड देन माइक्रोन्यूट्रिएंट्स। तो जो लास्ट स्लाइड में मैंने दिखाया था, जो स्टैंडर्ड्स हैं उसको फुलफिल होना चाहिए, तो उसके लिए ये सारे पैरामीटर्स हमें चेक करने पड़ेंगे। ओके, ये कुछ स्टैंडर्ड्स की लिस्ट है जो हम रेफर कर सकते हैं ये सब एनालिसिस वगैरह के लिए, या जो मेनली ये स्टैंडर्ड में हमने इनको रेफर किया है। Okay, I acknowledge my ministry, MNRE, my institute, BIS. Then ये कमेटी इन्वॉल्व थी इसको स्टैंडर्ड्स को फाइनल करने के लिए, ये हमारे इंस्टीट्यूट से कमेटी थी, सो आई वाज द कोऑर्डिनेटर। देन ये कमेटी कंस्टिट्यूटेड बाय BIS जो इस स्टैंडर्ड को फर्दर रिफाइन किया था। थैंक यू। तो
Thank you, sir. Thank you very much. Your presentation was really very good and informative. You have covered a theme that is waste to resource and employment. It is a very good topic and it is a demand of nowadays. And sir, I have learned a lot of things from this presentation, means digester, collector, and then purification aspect. What is small and medium and large scale digester? What is their range, and which type of we can say feedstock used during biogas generation and biogas digester. Few terms are maybe some students are not aware with that. OLR, HRT, yes, maybe they are not aware with that actually. But beside this, we have also learned we have to maintain we have to characterize the feedstock before going to start any digestion process, and that is very essential part before going to start any process development. Maybe that is the biogas digester. And particle size also play an important role. There are some temperature, pH, and phosphate ratios will crucial, play very crucial role. We have to optimize these variables before going to start or to get better biogas yield. And you have also told us regarding sampling analysis for running biogas digesters. This is a very good and informative session for us. Sir, I have one question regarding that. Not every time means हमेशा जो होता है ये नहीं होता है कि एक लिस्टेड पीपल और जो साइंटिफिक पर्सन है या वही बायोगैस डाइजेस्टर रन करता है। हमारे गांव में भी गवर्नमेंट बोल रही है कि इस तरह के डाइजेस्टर लगाया जाए और उससे चाहे वो कुकिंग के लिए ले जा रहे हों या फिर इलेक्ट्रिसिटी जनरेशन की बात की जा रही है। तो सर इसमें सबसे बड़ा प्रॉब्लम ये हमने देखा है कि मुझे लगता है कि जो ये आपका फीड देते हैं, फीड का कंपोजिशन वेरी करता है और वो उनके लिए थोड़ा सा मुश्किल हो जाता है कि टू मेंटेन दैट फीड रेट और यू कैन से दैट फीड कंपोजिशन, तो उससे कैसे वो कॉप अप कर पाएँ। और दूसरी चीज़ है, अगर जैसे हम सर प्यूरिफिकेशन बायो CNG की बात करते हैं, CNG जैसे वीके विजय सर देखा था मैंने, CRDD में काम करते थे तो काफ़ी अच्छा था उनका। तो ये उसमें बहुत बड़ा प्रॉब्लम आता है प्यूरिफिकेशन। तो प्यूरिफिकेशन वगैरह अगर CNG के लिए जा रहे हैं तो कैसे किस तरह स्क्रबर्स यूज कर सकते हैं, क्या उनके सिलेक्शन क्राइटेरिया क्या हो सकता है, ये सब थोड़ा सा माइंड में क्वेश्चन अराइज हो रहा है। तो सर चाहूँगा थोड़ा सा इस पर प्रकाश डालिए। तो
ओके, तो जो मेजर चैलेंज है वो यही है, जो हाउस होल्ड और जो स्मॉल स्केल के बायोगैस प्लांट्स हैं वो सक्सेसफुल मतलब पहले नहीं रहे थे, बट अभी लोग उसमें काफ़ी लोग मैच्योर हुए हैं, प्रॉब्लम्स भी पता चली हैं, उनको डील करने का तरीका भी पता चला है। अभी कुछ डेवलपर्स का मैंने इंस्पेक्शन किया था मेरी टीम ने, एक बैग टाइप के बायोगैस डाइजेस्टर्स आए हैं अभी लास्ट 2 इयर्स 3 इयर्स से लोगों ने आई मीन वो फील्ड में इंस्टॉलेशन किया है। तो हम लोग इंस्पेक्शन के लिए गए, तो वहाँ पे क्या होता है, जिसके पास जितना फीड स्टॉक अवेलेबल है, जैसे काउडंग बेस्ड है, तो वो उस चीज़ को ध्यान में नहीं रखते कि हमें डालना कितना है, उनके बायोगैस डाइजेस्टर का साइज क्या है, उसमें कितना डालना चाहिए। जैसे मान लो 1 मीटर क्यूब का प्लांट है, उसमें हमें 20 kg काउडंग डालना होता है और उसको इक्वली अमाउंट ऑफ वाटर उसमें ऐड करना है। आई मीन 20 kg है तो 20 kg पानी डाला, देन आप फीड करो। लेकिन क्या है, किसी दिन काउडंग कम रह गया या किसी दिन ज्यादा हो गया, तो वो सारा का सारा उठा के उसमें डाल देते हैं। ठीक है, अब एक और चीज आती है टेम्परेचर। जैसे हमारे नॉर्थ इंडिया में वेरिएशन बहुत ज्यादा है, अभी विंटर्स में टेम्परेचर इतना डाउन हो जाएगा कि आपका गैस भी बनना बंद हो जाएगी। ठीक है, बट आप उसमें भी फीड करते रहेंगे, या सपोज टेम्परेचर आई मीन कुछ है, सपोज 25 या 30 भी है, आपकी फीडिंग उतनी ही रहेगी, तब भी आपकी गैस कम बनेगी और टोटल डाइजेशन नहीं होगा। तो उस केस में क्या है, आपको फीडिंग कम करनी है। तो वो सब चीज़ें इंस्ट्रक्शंस या जो यूजर है उसको पता होने चाहिए। जब नहीं पता होते तो फिर उसका प्रोडक्शन पे या डाइजेशन पे फर्क पड़ता है। तो अभी जो कुछ नए डेवलपर्स आए हैं, उन्होंने अपना कस्टमर केयर या एक सपोर्ट टीम बना के रखा है। तो यूजर को जैसे ही पता चलता है कि भाई उसका गैस कम बन रहा है, क्योंकि आजकल जो आई मीन यूज बेस्ड प्लांट्स लोग लगवा रहे हैं कि उनको वो जो गैस है वो यूज करनी है अपने किचन में। एलपीजी महंगी हो गई है, इलेक्ट्रिसिटी भी महंगी है, तो ये एक अच्छा ऑप्शन है। तो वहाँ जब यूजर को या फार्मर को ये लगता है कि भाई गैस कम बन रही है, खाना नहीं बन रहा है, तो फिर वो कंप्लेन करेगा। तो क्या है, जो उनकी जो टीम है, सपोर्ट टीम है, वो आगे उनको जो भी चीज़ है वो बताएगी या जो प्रॉब्लम्स हैं वो रिजॉल्व करेगी। तो इस तरीके से सिस्टम अभी नई प्रैक्टिस इस तरीके से आ रही है। दूसरा क्वेश्चन आपने भेजा प्यूरिफिकेशन का है। प्यूरिफिकेशन में अभी बहुत सारी टेक्नोलॉजीज हैं। जैसे आईआईटी दिल्ली की बात की तो वो लोग वाटर स्क्रबर्स यूज कर रहे हैं। वाटर स्क्रबर्स में आई मीन वाटर कंजम्पशन बहुत ज़्यादा है। अब उसकी कैपेक्स और ये आई मीन कॉस्ट कम पड़ेगा, ऑपरेटिंग कॉस्ट और इंस्टॉलेशन कॉस्ट, पर वाटर और वो सब कंजम्पशन बहुत ज़्यादा होता है। ठीक है, और भी जितनी भी टेक्नोलॉजी है उनके प्रॉस एंड कॉन्स हैं। आई मीन कुछ के एडवांटेजेस हैं, कुछ तो दूसरी तरफ डिसएडवांटेजेस भी हैं। ऐसे ही एक मेम्ब्रेन टेक्नोलॉजी है, उसमें क्या है, कॉस्ट ऑफ इंस्टॉलेशन बहुत ज़्यादा है, बट वो मेम्ब्रेन की लाइफ पे भी डिपेंड करता है कि वो कितना टाइम चल रही है, तो आपकी कॉस्ट वहाँ से रिकवर होगी। ठीक है, ऐसे ही कुछ अमाइन स्क्रबर्स हैं, आई मीन केमिकल बेस्ड स्क्रबर्स हो गए, या आपका पीएसए है, प्रेशर स्विंग एब्जॉर्प्शन हो गया, है ना। तो इस तरीके से कई अलग अलग मेथड्स हैं और उनके प्रॉस एंड कॉन्स हैं। जो मार्केट में जो डेवलपर्स हैं वो अपने अपने बिजनेस चला रहे हैं, जो जिसको जैसे आई मीन स्टेक होल्डर को कन्विंस कर ले। मेन कंसर्न हमारा रहता है कि एमिशंस कम होने चाहिए, मीथेन लॉस कम होना चाहिए। आप मीथेन लॉस कर रहे हैं मीन्स आप CO2 आप जितना भी लॉस कर दें कोई प्रॉब्लम नहीं है, बट मीथेन मीन्स ऑलमोस्ट 20-21 टाइम्स ज़्यादा उसका इफेक्ट रहता है ग्रीन हाउस गैसेस का। ठीक है, बाकी तो जो स्टैंडर्ड मैंने दिखाया था उसको फॉलो करना है। और इससे मेन तो ये जो मुझे टॉपिक दिया गया था एम्प्लॉयमेंट वाला, उस पर मैं नहीं बोला एक्चुअली। उसमें देखिए आप सेल्फ एम्प्लॉयड हो सकते हैं या इस तरीके के बिजनेस क्रिएट करके। आजकल तो आपका स्टार्टअप्स बहुत चल रहा है, गवर्नमेंट ने इतना प्रमोट किया है, तो स्टार्टअप चलाओ, लोगों को भी जॉब दो, तो ये एक अच्छा ऑप्शन है। गवर्नमेंट भी बहुत सब्सिडी दे रही है, वो सब्सिडी वाला ओके सॉरी वो मैंने इंक्लूड नहीं किया, मैं कर सकता था। जैसे आपको लार्ज स्केल प्लांट्स में लाइक अप टू 5 टन्स बाय सीएनजी आपको करीब 4 करोड़ तक का सब्सिडी मिलेगा गवर्नमेंट ऑफ इंडिया से। ओके, छोटे स्केल पे मे बी लाइक 1 मीटर क्यूब और 2 मीटर क्यूब देयर इज लाइक 6000 और समथिंग और 12000, आई डोंट रिमेंबर, मैं भूल गया, नहीं तो मैं स्लाइड में इंक्लूड कर देता, वो एमएनआर की वेबसाइट पे अवेलेबल है। तो ये तो गवर्नमेंट ऑफ इंडिया का हो गया। इसके अलावा स्टेट गवर्नमेंट की भी अपनी अलग स्कीम्स हैं। जैसे यूपी में मैंने देखा गवर्नमेंट 1 रुपी में आपको लैंड लीज पे दे रही है फॉर लाइक 30 इयर्स और समथिंग, तो आप प्लांट सेटअप कर सकते हो, ठीक है, और लोन भी इजीली मिलता है। कुछ कैनरा बैंक, स्टेट बैंक ऑफ इंडिया, पंजाब नेशनल बैंक, तो कुछ बैंक डेजिग्नेट किए हुए हैं लोन के लिए। और जैसे डीपीआर वगैरह होता है तो वो हमारे पास आता है वैल्यूएशन के लिए, ठीक है। तो ये सब अभी चल रहा है, काफ़ी मार्केट पिकअप हुआ है, बहुत क्वेरीज आते हैं, लोग इंटरेस्टेड हैं ये सब लगाने के लिए। तो यही एक एम्प्लॉयमेंट का अच्छा ये है, आई मीन ये सेक्टर में काफ़ी प्रोग्रेस हो रहा है। तो और कोई क्वेश्चन है किसी का? अच्छा, एचआरटी और ये सब मुझे बताना है क्या? एक्सप्लेन कर सकता हूं।
Actually, UG students are there. That's why I asked you regarding that.
HRT जैसे hydraulic retention time, the time required to digest all the biomaterial, bio component available in the body, वो हम HRT कंसीडर करते हैं।
Okay. सर, अगर कोई बच्चा मीन्स कोई UG स्टूडेंट या PG स्टूडेंट अपने लैब में इस तरह का कुछ बायोगैस प्रोडक्शन से रिलेटेड एक्सपेरिमेंट परफॉर्म करना चाहता है या ऑप्टिमाइजेशन करना चाहता है, उसके पास हाई एंड इंस्ट्रूमेंट नहीं है, जैसे आपने कुछ जीसी वगैरह की बात की, तो क्या ये पॉसिबल है कि कुछ इस तरह का एक्सपेरिमेंट लैब में किया जा सके बाय यूजिंग सीरम बॉटल्स एक्सेट्रा?
सिंपल मेथड मैं बता देता हूँ, जीसी करना भी जरूरी है। कुछ इक्विपमेंट और है, मुझे याद नहीं आ रहा है, कुछ ग्लास बेस्ड आते हैं जो बहुत सस्ते आते हैं, 3000 4000 में आते हैं।
ओके ओके,
मुझे अभी याद नहीं आ रहा है, तो मैं बता दूंगा। अदरवाइज सबसे सिंपल मेथड, अगर बायोगैस प्रोडक्शन चेक करना है कि हुआ है कि नहीं गैस प्रोडक्शन, तो आप उसको बर्न करके देखो गैस।
ओके,
ठीक है, अगर गैस का बर्न कर रहे हैं, आपकी येलो फ्लेम आ रही है तो मे बी लाइक 45% 50%, है ना। अगर वही ब्लू कलर में अगर फ्लेम आ रही है तो समझो 55 प्लस में आपका मीथेन कंटेंट।
that is discussed by scientific community.
नहीं,
just to qualitative test actually. Okay.
अगर कोई टेस्ट नहीं है इसके बाद तो आप, अगर आपको लगा कि गैस बन रही है तो आप उसको किसी बैलून में या कुछ ये गैस कलेक्टर्स आते हैं वहाँ कलेक्ट करो, कहीं पे भी भेज दो, मेरे यहाँ भेज दो।
ओके ओके,
मैं चेक करके बता दूँ।
ओके सर, थैंक यू सर।
So that's why we were asking कि अगर हमारे यहाँ से कुछ students if you give us an opportunity to visit and get a training opportunity in your lab.
हाँ, ट्रेनिंग हम लोग जनरली 6 मंथ्स के लिए जो ट्रेनिंग के लिए आते हैं उनको प्रेफर करते हैं, ताकि वो उनसे एक्चुअली हमें भी सपोर्ट मिलता है, जैसे मैन पावर हम लोग यूज कर सकते हैं किसी भी प्रोजेक्ट में, एंड they can learn.
And one more problem existed with the biogas actually, that is the moisture content, sir. How we will remove that moisture content?
मॉइस्चर के लिए मॉइस्चर एब्जॉर्बर्स रहते हैं, या आप टेम्परेचर डाउन कर दो तो वैसे ही ये मॉइस्चर कंडेंस हो जाएगा।
Okay,
या प्रेशर भी थोड़ा अप्लाई कर दो तो कंडेंस हो जाएगा।
it is very nice. Sir, if our student visited your lab, is there any fees etc?
नहीं, फीस नहीं।
Okay sir, thank you sir, thank you very much.
थैंक यू फॉर इनवाइटिंग मी। होप कि सभी को कुछ लर्न करने के लिए मिला,
और कुछ सीखने को मिला सर। Anybody asking any question? I think Arvind Kushwaha raised hand
And Charu Vyas also had raised her hand.
two questions are there.
Anybody, any question? One question, sir, one of the student has asked that, sir, we are working on agro waste material, right? Every now and then हम सभी लोग बात करते हैं कि एग्रो वेस्ट मटेरियल है, हम इससे बहुत सारे बाय प्रोडक्ट्स क्रिएट कर सकते हैं विद द हेल्प ऑफ बायो प्रोसेसिंग। क्वेश्चन यहाँ पे ये आता है सर कि जिस तरीके से हमारे एग्रीकल्चर सेक्टर में केमिकल फर्टिलाइजर्स का यूज होता है, वो तो कहीं ना कहीं कंटामिनेटेड है इन केमिकल फर्टिलाइजर से। तो जब हम इनके ही वेस्ट मटेरियल से कोई प्रोडक्ट बनाएंगे तो क्या परसेंटेज होते चांसेस कि वो प्रोडक्ट प्योर हो, जो यील्ड हमें मिल रही है वो केमिकल कंटामिनेटेड ना हो? ये कैसे सॉल्व होगी ये प्रॉब्लम? एग्रो वेस्ट मटेरियल अगर एक सबस्ट्रेट है और वो कंटामिनेटेड है केमिकल फर्टिलाइजर से, तो फिर हम कैसे कह सकते हैं कि कोई प्रोडक्ट क्वालिटी बेस्ड है?
हाँ, तो केमिकल फर्टिलाइजर तो इतना डेंजर नहीं है, बट जो आप पेस्टिसाइड्स और ये सब यूज करते हैं ना, ये ज़्यादा डेंजरस होते हैं। तो इनका इम्पैक्ट आपका आई मीन स्ट्रॉ में भी रहता है, आपके जो ग्रेन्स या सीड रहता है उसमें सब में इम्पैक्ट रहता है। बट जहाँ या लास्ट में मैंने बताया ना, डाइजेस्टेड स्लरी और बायो फर्टिलाइजर, दैट इज वन ऑफ द ऑप्शन। आप धीरे धीरे केमिकल फर्टिलाइजर को रिप्लेस करो। अभी हमने यहाँ पे एक एक्सपेरिमेंट लगा के रखा है बीट के साथ में। एक हमने केमिकल यूज किया, मीन्स यूरिया फीड कर रहे हैं, एक में कुछ भी फीड नहीं किया है, एक में हम अपनी डाइजेस्टेड स्लरी फीड कर रहे हैं, और उसमें फिर हम शूट और उसकी लेंथ और वो सब करके देन अल्टीमेटली कितना स्ट्रॉ में मिलेगा, कितना ग्रेन्स मिलेंगे, तो वो एक स्टडी हम निकाल रहे हैं। बट ऑलरेडी स्टडीज अवेलेबल हैं। अगर आप एनपीके रिच बायो फर्टिलाइजर यूज करते हैं तो दैट इज ऑलमोस्ट कंपेरेबल विद द केमिकल फर्टिलाइजर। ठीक है, ऐसे ही पेस्टिसाइड्स का अल्टरनेटिव आई डोंट नो, क्योंकि पेस्टिसाइड तो केमिकल्स बहुत ज़्यादा खतरनाक है, उसका अल्टरनेटिव क्या है वो लोग उस पर भी काम कर रहे हैं, देखते हैं क्या आता है। और कोई क्वेश्चन है किसी का?
Before going to close this session, we would like to thank Dr. Sachin Kumar sir to join us on the behalf of Department of Biotechnology and Directorate of Research, AKS University, and on the behalf of the Dean, Student Welfare, Dean Biotechnology Department, Dean FSLT, and Chairman sir, Pro Vice Chancellor Shankar, whole AKS family will privilege to for you sir for joining us. Thank you sir, and thank you sir. Participant, we will join again after 1 hour lunch break. Okay, please be with us.
We have a last session on life cycle assessment, and the speaker would be from France. His name would be Kaisan Amisho. So Professor Kaisan will join us soon after the lunch break. So we'll meet again on the same platform. Till then, take care. Goodbye. Thank you.
बायोचोरी बनना है क्या? तो लड़का करके जाना है रैली में, वो कैसे मिलेगा हम लोगों को? वो मैसेज आया था कि डीलर के पास से मिलेगा, कोई मैं सोचा एक बार यही हूँ तो कंफर्म कर लूँ। अब तो मार्शल में तो आया है ना मेरा। हाँ, कौन सा झंडा? कौन सा झंडा? भेज दो ना, उससे भेज दो ना, नरेंद्र से भेज दो ना, भेज दो। हाँ